Alright, who's ready for another Ratrig live stream? I'm hoping today we can figure this bad boy out and get it printing. So, I've got most of the mechanical build finished. I just need to put together the electronics, so that's what we're going to be focusing on today. First thing I need to do, well, first thing I'm going to do, is put some of these little brass inserts into this part. So, we've got to use some fire. Alright, here goes. I just give these a 10 count on my little butane torch. That adds just the right amount of heat to press these in. Alright, so I'm just going to put 4 of those into this piece so I can put it together. And feel free to say hi in the chat. We got a couple people joining us this Easter Sunday. Hopefully you aren't watching me from church, because you might get in trouble. Alright, 2 more of these to go. If you have any questions, just let me know in the chat. Also, I got to do some fan selection. So originally, I wasn't planning on installing the fans, but I think it'd be a good idea to put some fans on here as part of the stream. And I'll let you guys help me figure out which ones I should use. I've got a box of like 100 fans. I think everyone probably wants to just see the Noctua installation because these are the nicest, but I'll go over the rest of our options too when we get there. Hello everybody. All right, we got some peeps in the chat. Alrighty. So I watched the ModBot live stream just on this portion of the build because the documentation gets a little bit sparse, so I'd like to see exactly how other people have put it together. But unfortunately, he skipped over a little bit of the assembly, so I'm doing the whole thing on stream. So maybe this will be a YouTube first. Alright, and let's put that brass insert. This one I heated up a little bit more. It turned that reddish bronzish color. It's fun how metals change colors based on how hot you get them sometimes. Oxidizing that copper into different states. If I get a VCore 3, I recommend you have someone else build it. Yep, that's probably a good idea. Otherwise, I'll have a 200-hour long live stream. But honestly, that sounds pretty fun. So, got all these pieces in. Now I'm just going to attach this. And hopefully that'll add a little bit more structure to my wiring area. So I'll just pop this in over here. And I need to find some appropriate fasteners. M3s all the way. Please use a soldering iron. I have a soldering iron, but why would I do that when I can use fire? Alright, now I'm just going to get this attached down here. I think fire is way more entertaining. Correct me if I'm wrong. Okay. The other tricky thing about this part of the build is the electronics box that I'm using isn't the same one that Ratrig has designed. So I'm going a little bit off the script here. But I definitely think having everything enclosed onto the printer is much better than having it be in a separate box. So we're just gonna take this and run with it. Okay, that screw's too long. Looks like we need a shorter one. So it was fun to see everyone printing out Easter eggs. Seems like that's a really common thing for people to want to 3D print for this glorious Easter Sunday. And it's kind of fun because you can use all sorts of different colors, and you can also print them halfway, put the piece of candy inside, and then print it the rest of the way, and then it's a seamless Easter egg that you actually have to break open. Fun stuff. Ooh, K1 release. Maybe I'll have to check that out. We'll see what's going on with the K1 release. Alright, I'm going to look it up on my computer over here. Creality K1. For anyone who doesn't know, the Creality K1 is... Oh, let's take a look. We've got some stuff on, I think, Twitter. Okay. Wait, we have the technology to do this in a better way. Let me switch over to my OBS software so I can just do a screen share. Alright. Hold on. Hold on. Alright. Display capture. I gotta switch it over to my other screen. Okay. Here's the K1 series. It looks like a Creality clone of a Bamboo Lab machine. Alright, we got a, looks like a glass or acrylic enclosure here. Oh, hold on. Let's get that full screened. Looks pretty good. Okay, so this looks like two different printers. So we got the one on the bottom right, it looks like a smaller version, and then one on the left looks like a bigger version. So I'm guessing this is the K1 on the right side, and then the K1 Max on the left side. So let's click to learn more. Let's see if we've got any more info on here. K1 Max. Alright, we'll go there too. Alright, K1, 600 millimeters per second printing speed, hands-free auto leveling, and boy, does it look like they took some inspiration from a certain other 3D printer. I got my dad into 3D printing, and he printed an Easter egg too. Yep, that's definitely one of the easy things to think of to print. Wow, and look at the size of these stepper motors in the back here. So these are larger stepper motors with a larger pulley gear. That's an interesting design choice. We'll see if it actually looks that way. Alright, and here's it actually working. And it looks like they pretty much copied the marketing material from Bamboo Lab. Now this clip on the left side looks a little bit odd. It looks like it's sped up because like when I film stuff, I'm very particular about the frame rate. So you can see how it looks kind of choppy, like stop motion. That's usually what happens when you speed up footage. So I'm not sure if this is a real time, or they're just trying to demonstrate this is what it would look like going 600, or if they just used a really crappy camera. But yeah, the printer's shaking around and it looks kind of like real time. They might have just not been using the right camera settings to make this look right. 13-minute benchy. Holy cow. That's an ABS. And this is apparently printed at 300 millimeters per second. I kind of doubt that, but you know, we'll get one in for review and try and validate their claims. So it looks like Creality is using a... Sorry, this is kind of a side, an aside here, but this is pretty exciting. So it looks like Creality is using a steel linear rod setup. So just based on the pictures here, I can't really tell. It looks like we've got a steel rod across here on the x-axis. And I kind of like that. Yeah, because having that carbon fiber rod is a wear component, and steel rods should last longer. I mean, I don't actually know, but it seems like that would be the case. We got a ceramic heater core. Get cool models on the fly. Okay, dual fans. That's nice. So dual part cooling fans might work a little bit better than what Bamboo Lab is using. We'll have to just see about that. This thing definitely looks the part of a great printer. And yeah, they just basically copied Bamboo Lab's site layout. Cool stuff. I'm excited to try one out, see what kind of bugs we can find. Oh, and look at this. They just copied almost verbatim what Bamboo Lab did for their marketing material. Just a close-up of it, watching the vibration compensation. Cool. Alright, well, I'm excited to get one in for testing. Ooh, $5.99. They're undercutting the P1P even. These are exciting times. What's everyone think in the chat? I'll read some comments. Rip off for sure, it's good for the market. Yeah, I bought the Bamboo last week. It looks like a copy paste of the Bamboo for sure. Printing at 600 is conditional no matter what. Really, only some models you'll be able to do it, and most you can, but probably shouldn't. Yep. It's definitely going to sacrifice some print quality when you're printing that fast, but that's always the case. Creality print 4.3 with speed genes. Well, I'm excited to check out those speedy genes. But yeah, Creality's sending one for me to review, so I'll be checking it out. You know, I'm always hard on the printers that I get in for review, so we'll put it through the ringer. Now we got the K1 Max, so they're beating Bamboo Lab to the punch in terms of making a larger fast printer. This one says 300 by 300 by 300 build volume. This one over here, I don't see the build volume of it. If anyone knows the build volume of this K1, drop it in the chat. Aluminum alloy heat bed. Yeah. Yeah, I'm not sure what the print volume is on this. This looks like Creality's normal print volume, so maybe it's 225 by 225. But yeah, it looks like they're... Oh, right here. How do they not say it anywhere on their... Oh, is it over here? There we go, 220 by 220. Okay, so this is smaller than the P1P, and it's in line with the size of the Ender 3s of the past. So it looks like they're kind of bookending the Bamboo Lab printers. So they're making a slightly smaller one for a cheaper price, and they're making a slightly bigger one, which is probably more expensive. I'm just going to scroll down to the bottom for the price. $999. Okay, so this is cheaper. Okay, I really like what Creality is doing here, but we're going to have to get one in and see how the quality forms up, because this is an enclosed, fully enclosed printer, so it's more in line with the X1 Carbon, and it's 300 by 300, and it's less expensive. So, yeah, these are exciting times to be in the 3D printer market. All right. Yeah, the Bambu Lab has many features that I love, like tip cleaning, purging, homing that works every time. Yeah, we'll have to see what type of homing this printer uses. They might have just copied the Bambu Lab homing procedure. Let's see, we've got, it looks like a single lead screw to move the Z-axis up and down. I might be wrong here. Let's see if there's any views of the bed. No, it looks like we've got 3 lead screws. So 1, 2, and then there's going to be a third one on the other side here. So triple axis lead screw. This one comes with a fan, possibly. We'll have to see what they end up doing. And I'm going to guess that they're just copying the Bambu Lab approach to homing, just because it's such a better solution and you don't have to program your own offset into the machine. That's the problem with any type of separate bed leveling probe. You end up having to manually calibrate the homing operation. But anyways, let's look at this K1 Max real quick. All right, 20,000 millimeters per second acceleration, 600 max speed, 32 millimeters cubed per second. I wouldn't be surprised if this could extrude faster than the Bambu Lab machine, because the Bambu Lab machine's using their proprietary nozzles and there's no opportunity to throw a CHT-like nozzle in there. And this one has a removable nozzle, so you can put a CHT in there if you want. And that should definitely unlock some higher print speeds. Wow. Hotend with the titanium alloy heat break and hardened steel nozzle. So, yep, carbon fiber materials up to 300C. Alright, this is going to be, if this thing lives up to expectations, it's going to be my favorite printer. Oh, and then they even put a little laser profiler scanner in there too, just to make sure they hit all the marks in terms of, I don't want to say ripping off, but in terms of being inspired by Bambu Lab. So, thanks Bambu Lab for figuring all this stuff out so Creality can copy it. So, that'll be fun. Let's keep an eye on things. Alright, and here we can see, this looks like they're using some kind of load cell under the feet. These look like load cells here. So I would wager that they're using the same bed leveling technology as the P1P. Looks like we got a decent camera built into the printer as well. AI detection stuff. Alright, it says Creality Cloud. We'll see. I don't like that. I really don't like the cloud capabilities of these machines. And we'll see what type of firmware it's running, but I mean, it looks like a great improvement based on what we've seen in the past, so cool stuff. That's the main negative. Okay, a serviceable a serviceable version of the Bambu. This would be excellent if this thing proves to be more serviceable, because that's one of my main problems with the Bambu Lab printer right now, is that you can't take it apart. It's like glued together, so if anything breaks, you have to send it back to them, which is complete BS in my opinion. Alright, rated power 1,000 watts. That might mean that they're using a AC heated bed for once. That might be a first for a that might be a first for a Creality machine. So we'll see. Exciting times. They're gonna send me out, I think, one of the first batches for the K1, and then the K1 Max should be delivered. If I'm thinking of this correctly, I think they're sending me a K1 Max too. So this is one of the things that I love about Creality. I've been so harsh on their printers just tearing them apart with every new release for all the little mistakes they make. But they still send me stuff, so that's I have quite a bit of respect for them for doing that. Okay, well, that's all very exciting stuff. Very, very cool. Let's get back to the printer of today's video, which is going to be this little thing right here. And I hope the photographers in the chat appreciate the bokeh we got going on in the background. I got my f2.8 aperture going on. I don't know if anyone knows what that means or cares, but that means we get blurry backgrounds. Okay, well, I mean, this thing's going to be completely antiquated by the time I finish it, because as soon as that K1 comes out, I'm not going to need this printer anymore. But that's just the way it goes in 3D printing sometimes. So I just got this little sidewall attached, and that's going to help hold everything in a little bit better. If anyone has any more comments or questions about the K1, I'll answer as best I can. So, let's see. There's an opportunity more put a CHT on if you get 30 part. Yeah, I've heard that about the Bamboo Lab printer, but they're not supporting it out of the factory, which is a little disappointing to me. Okay, so this goes up here. I gotta hurry up this build because, you know, as soon as that K1 gets in, I'm not gonna have any time to work on this thing. Because I'll have to be making comparison videos, reviews, and whatnot. Alright, so manual homing is really annoying when you get clogs. Yep. This will print faster than the Bamboo Lab printer. We'll see about that. We'll see about that. It really comes down to how good Creality can tune their slicer, because that's been kind of a real weak point with Creality machines for quite a long time. Their slicer settings are just not really tuned in to get the most out of their machines, because all their printers have been rather slow up until now. Oh shoot, I snipped the wrong one. Okay, I'm gonna start cutting these zip tie tails off just to clean this up a little bit. And yeah, that's looking good. Sorry for getting my big head in the way, but I think this will work well enough even after we install our little top cover here. That looks pretty good. We do have it pop out right there. Sweet. And okay, and then I'll get all the rest of my wiring up in here. So here's all the wires from my the Hotend, and this is gonna be a little bit tricky. So here goes. I don't know. I have my Bamboo running at half speed for everything. It was too fast for my liking before. Yeah, held together using 3D printed parts. Essentially, 3D printers are more intuitive. Why do so many printers act like this? Yeah, well, this is like an open source kit build, and so is the Prusa MK3S. So, and MK4. So that's kind of the philosophy that they've gone with. I don't think holding things together with 3D printed parts is a problem as long as the 3D printed parts are strong enough. So that's not too much of an issue in my book. I think if you're going for high performance and lower cost, then injection molded parts pretty much always makes more sense than 3D printed parts, because injection molded parts are stronger and cheaper to make. Alright, so I gotta put some JST connectors onto this little thing here. This is for the bed leveling probe, so I need to put some of them little JSTs on there. We'll see if we can do it. I'm not sure exactly how this gets plugged in, so I need to pull up the wiring diagram. So I am using the SKR2 or something. I'll take a look at it right there. So let's zoom in on this full-size wiring diagram. That's not the one I want. Although that's interesting, I get, wow, 4-pin fan control. That's interesting. Neat. And then we'll look at this full-size wiring diagram. So this is where I've got a couple of questions. So place green jumpers and remove others. Okay. That's going to be annoying because now I have to open up the printer to get that. This is the wrong one anyways. This is the Octopus. It's got 8 stepper drivers. We don't need that. So back here. This is the SKR, Big Tree Tick SKR2. Yeah, this is the one I want. Now I'm not going to use the X and Y end stops because I would rather just do sensorless homing because I think this board can support that. But now let's see. This is tricky. So it looks like 2 of the wires from this inductive probe. Looks like 2 of the wires go to one connector here, and 1 wire goes to the other connector here. So, with that in mind, let's try and make that happen. So, one of those is a 2-pin JST. One of them is a 3-pin JST. I'm going to have to get a couple of these crimped things out. Alright, but I'm curious in the chat, who are you rooting for? Do you want to see Creality come out with a machine that wipes the floor with Bamboo Lab? Or do you want to see Bamboo Lab hold on to the lead, or some other competitor to enter the market? No wonder the Ender 5S1 went on sale so quickly, yeah. Yep, it looks like this is a much better deal. Because it's only slightly more expensive, but a lot more performance for the K1. But we'll see, maybe the K1 is going to be a pile of junk when I get it. This is why I gotta see it in person before I really express any opinions on it. Alright, so, you know, this is kind of the annoying part about one of these kit printers. You need to have all these specialty tools to do the wiring. So I'm breaking off all of these little JST crimps. And this is a skill I learned a long time ago, and it's definitely paid dividends on working on 3D printers and electronics. So learning how to use these crimping tools. These guys right here. Yeah, they got... This bokeh's out of control. I'm going to stop it down a little bit to make a little less background blur. But, yeah, you've got these little pins and stuff. You need to load up the crimp bits, which takes a little bit of experience and practice. And it's not super fun, like in the amount of time that it takes to do one of these crimped pins. Ah, crap, I just dropped one. I just dropped the crimp inside of the tool. There we go, came out. But in the amount of time it takes to do one of these crimped connectors, you can probably unbox and get running a pre-assembled printer. So I don't know if it's really worth the time. Just depends on what your priorities with your 3D printing life is. Okay, so I just got to crimp these on. So the way I'm going to do this is I'm just going to crimp all 3 of these connectors. And then I'll get all 3 of these wires terminated with these crimped connectors and then stick them into the JST plastic housings in the right order. Creality needs to wipe the floor with bamboo, and bamboo needs to hit them back hard. Yeah, that'd be interesting. Yeah, bamboo, I talked about this in the latest episode of my podcast that I do with Guy and JJ called The Perfect First Layer. But the episode isn't out yet, but I was talking with them about how much money these 3D printer companies make. Like, if you were to guess, how much money do you think Creality makes in a year? Just throwing some numbers out. I don't think this worked right. JST connectors are so finicky and small, it's kind of hard to see what's going on with them. I'm not sure if this crimper dealy fastened itself correctly. So I'm going to have to go in here and solder it just to make sure. Now this isn't a good practice. You should probably just cut the wire short and put some new stuff on there, but I'm a professional. And I've got access to delicious leaded solder, which is much better than the non-toxic solders that you get access to in other countries. Okay. It's hot. Alright, hopefully that'll work. Yes. I doubt the K1 is an existential response. We'll see about that. I mean, they're sending me a review unit, so, you know, take my experience with a grain of salt, because you can bet that they've put a little bit more testing into the one that they send me than the one that you'll buy yourselves. People are putting some interesting price tags in the chat. Borderline inappropriate, you guys. You and your meme internet culture. What will Prusa do? They still charge $1,300 for a POS. Yeah, that's a good question. The only advantage I can see to the Prusa machine at this point is it's made out of orange plastic. So if you like orange plastic, then that's definitely the machine for you. Alright, so I got my 3 little wires wired up here. And the easiest way to do this and make sure you do the wiring correctly is to, I'll just kind of move this in place so you can have a good look on how I'm wiring it up. You afraid to get some flux on your hand, bro? Lol. No, I got some some molten lead on my hand, which it's probably not good, but it's fine. I have soft hands. I sure do. Alright, so let's see. Wiring diagram says, well, you can't see it on this picture, but I've got it on my computer screen. We'll blip over there. So let's see. So this far right side one, I put 2 into that one, and then the 3 plug one, I put 1 into the middle port there. So that's over here. So I'm just going to take this empty plug housing and just put it right there. And do the same for this. And then I'll just go ahead and install these into the right spots. So we've got our black wire right here. So I shove that in place and it locks into place there. Next up is blue wire. Oh, by the way, we reached 15,000 subscribers yesterday. So that's a sweet little benchmark. I don't know if I ever imagined having that many viewers and subscribers on YouTube, but I want to give a huge thanks to everyone that's subscribed. I bet everyone here is already subscribed, so I'm not going to plead with you to subscribe to the channel, but if you have, you know of anyone who likes 3D printer content, I would not be upset if you shilled for me, so just let people know to check out the channel, to subscribe, and whatnot. Okay, so we've got our wires plugged in there. That wasn't too difficult. I need to take this one and plug it in right here. This is my extruder stepper motor, so that goes right here. Pow. Alright, then we got 2 fans. I'm just planning on powering the fans. Let's see. Let's see where those fan ports are. I think that they're right here, but I'll take a look at the diagram. Let's hop over to our wiring diagram view. Okay. Come on. Okay, so looks like we've got Hotend fan and part cooling fan. That's the ones I want to use, so I'll plug them in accordingly. So it looks like the part cooling fan goes on the bottom in this view, and the Hotend fan goes in the middle in this view. So let's do that. So Hotend fan, part cooling fan goes on the bottom like this, and Hotend fan goes right here. There we go. Nice and easy. Okay, so this all is happening faster than I thought it would, so this is good to see. All right, next up we've got our Hotend thermistor. So in the wiring view, it gets plugged in Oh wow, we got a little place to plug in an ADXL also. So I'll have to set that up later when I do the fine tuning for this machine. Getting input shaper will be pretty sweet. Where is that Hotend though? Here we go. Hotend thermistor. Purple wires gets plugged in kind of one from this corner. So let's go back to our real life view. That should be right here. Welcome to real life view. Alright, and I think that's it. Oh, I got my Hotend heater wires here. So I think I know where those go, but let's just double check. So the nice thing about this board is it can actually support dual Hotends, but I'm just using one right now, so I'll just go with their default configuration, which is this one that's more towards the middle. So let's check it out. That'll be this one right here. So I just gotta plug these wires in right there. And I don't think the order matters here because basically this is just a resistive element, so the positive and negative terminal doesn't matter. It's a non-polar component. Alright. Plug goes in and tighten it up. Now the polarity does matter when you're wiring up the hot end for a Sprite or some other extruders, because they like to piggyback and combine wires onto a single common ground or a common power rail, which just makes things more difficult than they need to be. I prefer to run individual wires for everything just because it keeps things a lot simpler. It prevents certain mistakes from ever being made, and it just makes for a more foolproof experience. We're all fools here that are into 3D printing, so you know, you gotta know your audience and plan accordingly. So the last thing that I'm finding in this wiring instruction that I find kind of odd is that they're telling me to remove a bunch of these little jumpers. And I don't know enough about this stuff. I'm not sure what these jumpers do. But does anyone know how I need to set up sensorless homing? I think I can look that up on the internet. But yeah, if someone can let me know, I want to set up sensorless homing on this machine. So if you have experience with this and you know how things need to be changed, maybe maybe I need to add a jumper to the top here, the top of these little stepper motor drivers. I did this before, so I should know how to do it, and I can consult one of my old videos if I need to. But I think you might need to add a jumper to like these little things sticking out the top. I'm not sure. You need to enable serial communication to these things or something like that. Not 100% sure, so some help in the chat would be greatly appreciated. I'm going to read some of the comments in the meantime if someone wants to help me. By the time I get caught up reading the chat, we'll see. So I'm just going to pull up the other screen with the K1 on there so you can appreciate some of the goodness here. Yes, promotional materials. Oh man, I'm sleeping and then I just woke up and I gotta slice it. Gotta slice. Oh yes, there's a female 3D printer user. Yes, she's gonna use the maximum capacity. Plug in the little tray there. The AI LiDAR taking care of the first layer. This is exactly what we need in our lives. Heat bed reaches 6 DC in only 90 seconds. That probably means they're using a AC heated bed. And he just threw a stealth bomber. I don't know if that's an act of war or what's going on. Oh, whoa, hold on. Those are some pretty big gear teeth there. It's a neat little design. Cool stuff. And then they got that same fan that a lot of people are using now. And they're just endlessly printing perimeters. They're never going to get to that infill. And yeah, he's got the cloud app. All right. There's the lady again. Yes. This looks like real printing footage, so it looks like they've been working on this for a while. Hold on. Hold on, what was that? Are those layer lines I see? Looks like a little bit of a ugly surface finish there. Maybe it's from having that, like, those tall pieces might be wobbling around a little bit while they're printing. We'll have to do some print quality tests on this thing. And ventilation, wow, this thing just looks great. Oh, the print quality looks like it improved now, so. Through the magic of TV cooking. All right, so, I don't know, looks pretty neat. Let's look at the comments a little bit more here. See if anyone in the chat is helping me with my stepper motor driver setup. 190 gram lightweight print head for less inertia, but they don't say how much the X gantry weighs, which is also important. But 190 grams is quite light. They must be using like a different stepper motor that they're using on the Sprite Hotend. Eat the lead. Okay, I mean, I've heard it's sweet, but I'm probably not going to eat it. Looks like Creality spent all their customer support savings on advertisement. At least their K1 webpage is pretty. Yeah. Well, I mean, K1, Creality is probably sold billions of dollars of printers at this point. So, I mean, I don't know if you guys realize how big this 3D printer industry is, but it's huge. I mean, the fact that little rats like me can survive making 3D printing content and get views on the internet should tell you something. Little rats like me with my Ratrig. So, I wonder, with the K1 coming out, would that mean if something breaks, we will be able to buy spare parts for it? I would hope so, but we'll find out. Spell Reality will no longer be able to sell you a $700 bed slinger. Yeah, I mean, I don't really have a problem with bed slingers personally, but they work good for PLA and P2G. I mean, when you start enclosing a bed slinger, that's when it doesn't really make sense to do it. I know Prusa is enclosing their bed slingers and they sell a separate enclosure. But really, it's not space efficient. If you want to enclose a printer, then it should be built in a Core XY design or some kind of cube printer. You just subbed. All right, Zetroy, thank you for subbing. Thank you very much. I like that this stuff is informative, but also occasionally he'll throw a joke that will catch you off guard. Yeah, that's probably going to get me canceled one day, but, you know, I got to keep things entertaining. Why do some people hate bed slingers so much? It's okay up to a certain weight. Yeah, I think bed slingers are fine. I've got a lot of bed slingers that have excellent print quality, and they're very cheap to construct and easy to understand. So, pretty good. Yeah. I mean, so Grothado's bringing up the point that there's better technologies out there, and moving and stopping the changing directions for the large mass of the print bed doesn't really make sense. But if you're trying to make a printer as inexpensive as possible, the bed slinger is the best choice. It's just there's less structural components that are required to put a bed slinger together, so it's always going to be a little bit cheaper to build one that way. Even better than that is the gantry printers, like what we have here, where you've just got one arm. You know, one arm bed slinger. This is probably the cheapest way to produce a 3D printer. Maybe a polar printer, the kind where the build tray rotates. I think that might actually be less expensive to produce in terms of the number of structural components needed. But those have their own issues due to the singularity at the middle, like when you're trying to print things in the middle of the machine. So yeah, just woke up, gotta go slice. Yep, that's how everybody lives their lives in this 3D printer world. I mean, he's like, his shirt is all ironed. It looks like he's got a very clean desk. I mean, that's not the type of person that falls asleep at their desk. I'm the type of person that falls asleep at my desk. And it doesn't look like that when I wake up. I mean, just look at this. I just woke up. This is how things are supposed to look. I wonder what the gear ratio is. Yeah. It's probably fine. I mean, the gear ratio doesn't really matter that much. There's a lot that can go into it, but basically your max speed is going to be determined by your gear ratio. And you don't need that large of a mechanical advantage to actually extrude stuff. Then it also depends on what kind of stepper motor you've specified, because if you're using a faster stepper motor, then you might want a higher gear reduction ratio. Wow, they made it look pretty good. Yeah, it looks great. I mean, it looks better than a Bamboo Lab machine. So they've definitely put their billions of dollars in 3D printer revenue into producing something that's actually good. So thank you, Bamboo Lab, for giving them a slap in the behind and tell them to get moving. We're finally seeing what Creality can do. Is the induction heated hot end? No, I don't think it's using induction heating. Let's go back to the little screen there. It looks like it's using a ceramic hot end. Let's scroll and look at it. Here we go. So ceramic heater encircles the hot end. This is like what the RatOS uses. I think the RatOS was one of the first major printers to use this type of technology. Either that or the Revo. The Revo, I think, uses this type of technology as well. So it uses a positive temperature coefficient ceramic heater. And the advantage of that is it self-regulates, so it can't overheat as easily. Basically, as it gets hotter, the resistance increases drastically, so you reduce the amount of power that can be delivered to the hot end. So that gives you the best of both worlds, where you can heat up rapidly when you want to start a print job, but once it gets up to temperature, the power delivery tapers off to the point where it's just maintaining the temperature at around 340 C, which sounds hot, but it's not hot enough to do any major damage. Versus our traditional hot ends that use those metallic heating elements, those can get up to like 1,000 degrees. Like they can really get extremely hot enough to make things burst into flames and melt aluminum. So these ceramic heater elements are definitely a good thing, and more printers should use this right here. Here. Okay. So enough of that side rant. Hopefully someone's going to tell me how to set these here stepper drivers up to do sensorless homing. If not, I'm going to have to browse the web and figure it out on my own, which is probably better than listening to random commenters, because I pretty much feel like I'm guaranteed to not solve the problem right if I listen to you guys. So let's look it up. Sensorless homing 2209. We'll see what the internet has to say. Well, I mean, I can't really watch another person's YouTube video on here under fair use, but I can sure as heck read people's YouTube Reddit comments. This is like all PewDiePie does nowadays. He just reads Reddit. BTR, yeah, sensorless homing. Let's see. No problems. All right. Well, I need a picture. I need a picture of how to do it. So I'm gonna switch back to camera mode, just so I don't get in copyright trouble. And I'm just gonna look at what other people are doing. It's called UArt, I guess. UART. Okay. Alright. So, I mean, at least I think what I should do is follow the guidelines that they set up in the installation instructions, which are telling me to remove some of those jumpers. So let's get it. So I have to pull all these out and remove jumpers. So we'll go back to the Ratrig wiring diagram. Alright, so take a look-see here. It says move the jumpers, I guess. So it wants me to move some of these jumpers upwards a little bit. Okay. I love playing with jumpers. Alright, so I need to remove all of these other jumpers except for the one on all of these stepper drivers that I'm using. And it looks like I need to move my extruder motor over a little bit, but we'll get there. Looks like it wants me to use E1 by default, so we'll do it. So yeah, I'm just gonna try and recreate this jumper configuration all across the board. So, time to pull some jumpers. Alright, and then I need to remove all of these jumpers except for one of them. So, here goes. If you want a close-up view, and I'll turn up the brightness a little bit. Alright, so pulling jumpers. Alright, I think this is what it wants. I hope I'm not pulling out the jumpers that it wants me to keep. Maybe I'm doing the opposite of what they want. According to the instructions, it says what does it say? Place green jumpers and remove the others. Okay, that's good. Well, let's do it. I'm gonna have a lot of spare jumpers here. I know King Sidorak probably wants me to mail them to him. Can't let these jumpers go to waste. So this is absurd. This is like a 12-hour process to put this printer together. I better do at least 12 hours of printing with this thing by the time I finish it. Otherwise, it'll be a real questionable use of time. So I think I've got this right now. It's got the one alright, yep, just got the one jumper there. And we'll put all these back in place. I actually did a video where I set up sensorless homing. That was one of my first videos. It was, I built a 3D printer that had 0 fans on the entire build. I used a CPU heatsink for the Hotend heatsink, and it was big enough that it didn't need any kind of fan blowing on it to keep it cool. That was a really nice video. So, you know, if you want to check that one out, feel free to after the stream. And I just realized I plugged this one in the wrong spot, so pull that out here. These are some tough connectors. Move it down here. These are from LDO motors, so this LDO motors connection is quite strong. I don't know what that says about their quality. Probably means it's good. Okay, so enough screwing around over there. So next up we've got our fans I'm going to wire up. So starting with this one right here, the one on the bottom has the little ground stripe on it. So I'll know what that is on the opposite end. And it looks like that little stripe is plugged in to the negative voltage side for the part cooling fan. So when we go up to the top here, we'll take a look at this wire. That little white stripe on the wire indicates that that's the negative fan, negative wire for the part cooling fan. So I'll just pull that apart. And I'm going to use some of my solderless connectors. These are handy because it's just really easy to connect fan wires. They're really low current, so you don't need anything special to get those wired up. So I'll just use that. Let's see. We want to use... Alright, this is the first community poll question. Do we want to use a Delta fan or a Sunon fan? Which is better, Delta or Sunon? Do we have any strong opinions in the chat? I'll leave it as an open question for, let's give it 1 minute. We'll put 1 minute on the clock and see what people are voting for. So, oh, nice, a new disappointment by Creality. Well, let's just wait to see it before we're disappointed. It might actually be good. Get a small print farm going on the side. Some people start with 1 printer even. Yeah, I'm actually thinking about doing that. I think that would be a good use of my time because, you know, as much experience as I have with 3D printing and modding 3D printers, I think it would add a little more credibility if I was running a print farm. I'd get to rack up those hours and really test out the printers that I've gotten for review. Also, I have a lot of experience with designing 3D printed parts, so I think I could definitely add some value to some people. And this is a great platform for advertising my 3D printer services. So if anyone wants me to 3D print them some stuff, I'll probably be setting up a website to make that happen in the near future. Just no strange requests. You know, you can ask me to print stuff, but it can't be weird. Okay, so I'm going to tidy up the wiring up here. Get some zip ties going. Okay. So I want to have enough slack wiring here so that if I ever need to take this apart, it's not going to be super difficult. So I think I'm going to get, oh jeez. So I think I'm going to kind of have some slack here. maybe about this much. All right, zip ties away. All right, and I can always recut these zip ties. That's not a big deal. Looks pretty good. Okay, so then I'll wire up this Hotend fan. Let's see what people are saying. Are we Sunon or Delta fanboys? And when I say fanboys, I mean it literally. Why is it so difficult? They've made a good English translation on their website? I don't know. Yeah. What are some of the funny English translations that you're seeing? I'm curious. So, let's see. Pull this tight. And give it a snip. Ask ChatGPT. Yeah, that's a good idea. They might be able to figure it out. Did you come with a Pi? No. It'd probably quadruple the price of the kit if it came with a Pi. Never put with PLA, so it doesn't matter. Yeah. Delta, which one is louder? Whichever has ball bearings. Both of them have ball bearings, I think. Well, I think the Sunon actually... I don't know. I think they both have ball bearings. Let's see. Let's give you some tech specs here. So the Delta is a 0.16 amp fan, and this is a 1.95 amp, so it'll be significantly weaker. If we're just going for strength, the Delta is definitely the more powerful fan. It feels a little bit heavier too. But these are fans that I don't know if I bought these. Yeah, I think I bought this one on DigiKey, so it's like a legit fan. Versus the ones that I buy on AliExpress, you never know what you're getting there. Sunon, we got one Sunon. What J Maxey said, whichever has ball bearings. I don't know how I'm supposed to tell which one has ball bearings. I want to see that K1 with pegboards on the side like one of the P1Ps. Well, yeah, I can do that. Just get a drill and drill some holes in it. I'm pretty sure someone will come up with a similar solution for the K1. Yeah. Alright. Well, we have one Delta and one Sunon. So I think that means, let's see. I think that means it comes down to a tiebreaker, which is me. So I'm going to go with this Delta fan. I think it's going to be louder, but it's probably more powerful. What's 24 times 1.6? Let's see. 24 times 0.16. This is almost a 4-watt fan. So since we've only got a single part cooling fan on here, it might be nice to just have a more powerful fan to make up for the lack of additional cooling. So here goes. Alright, so I just trimmed that, and then we'll put the negative wire to that white striped wire right here. I'll use one of these little solderless fan connectors here, and then just give it a little pinch. There we go. Just give them a little squeeze, and that should secure the wires there. We'll do the same thing on the other one. So just put them in here. Make sure your wires are getting seated all the way. So it's easy to not get these all the way seated, but yeah, you just want to make sure the wires are all the way at the bottom. There we go. Yeah, that's all the way at the bottom. And just give them a little squeeze. And there you go. Just like that, we made our electrical connections. So next up, we're going to do the Hotend fan. I've got a lot of options for Hotend fans. I've got the Noctua, which I feel like is always a good choice. So I think I'm just going to go with that. Now in this case, I'm using a Noctua fan. This is from the 3-pin fan kit. And if you buy the 3-pin fan, it comes with 2 low noise adapters. One of them is like an ultra low noise adapter, and one of them is a regular low noise adapter. And basically, when you add those 2 resistors up in series, you end up with the correct amount of resistance to run this 12-volt fan on a 24-volt system. So I really highly recommend getting one of these 12-volt 3-pin fans and just using these 2 low noise adapters in series. And that has worked out really well for me on a couple of my builds, so I think it's working just fine. I can do that, or I've also got some fans by CUI Devices, which is a pretty sweet fan brand. I'll show you the box. This is only about half of the fans that I have here. Just a whole box full of fans. There's about maybe 40 in this box. This is only about a half or a third of what I have. So I tested out a ton of different fans, and I found that these ones from CUI Devices were the cheapest and quietest for how much air they move. But Noctua is still better than those. So Noctua's #1, CUI Devices is the best cheap brand. I tested a lot of these Sunon axial fans, and I found that they were quite loud. They weren't very good at all. So when it comes to Sunons, I just like them for their 50-15 fans. And when it comes to axial fans, it's Noctua all the way, with the second place going to CUI Devices. So that's what I learned from testing 80 plus fans, which probably wasn't a good use of my money, but we learned something out of it, so it was worth it in a way. Okay, so we got our Delta fan installed here. Let me put a screw in just to hold it in place, and we'll move on with the build. We got this box of screws. Always handy to have a box of screws. I think I need a 20 millimeter. Grab that, and let's see. Nope, looks like I need a 25 here. 25 millimeter screw. There we go. Perfect. Alright. Alright, any minute now I'll find the right tools to be able to install this fastener. So, I mean, this is how it goes. This is how this whole stream's been, just slow and steady progress. I think we're almost done here, despite how messy everything looks. It's coming together quite well. Then I need to install RatOS. Okay, that's good. What next? Yeah, right, the Hotend cooling fan. I think I'm gonna just go with the Noctua, the tried and true best fan ever. This one right here. I would use a smaller one if I had one on hand, but I'm just gonna use this one because this is what I have ready right now, and we're ready to start printing. So let's just use it. All right, so 12 millimeters screws it is for here. And I need to find the right size Allen wrench. So I'll flip this around. I know I don't want to leave you in the dark on this build here. I know you're all following along at home with your Ratrig V-Minion kits. I mean, the crazy thing about that K1 is it's the same price as a full Ratrig V-Minion kit. So in terms of value, as long as it's actually a decent printer, that K1 should be pretty awesome. But the Ratrig V-Minions, you know, it's definitely that kit printer experience where you're just having fun building stuff. That's got its own, that's got a value proposition of its own. Okay. Man, I'm really excited to test that K1 and pit it up against the P1P. If anyone has ideas you want to drop in the chat of comparisons I can do between the P1P and the K1 once I get both of them side by side, just let me know and I'll do it. Now, as far as I know, the P1P and Bamboo Lab does not have an affiliate program, so that's one thing is that, you know, creators like me, when you make a video, you put little links into stuff and you get little affiliate kickbacks. I don't think Bamboo Lab has set those up, or at least they haven't told me about it, probably because they don't like me. But yeah, Creality has affiliate links. I don't let that color my judgment too much. Like, I just like building stuff and doing comparisons, so I would hope that that doesn't affect the content that you see, but there's always going to be that small amount of subconscious bias even among people who don't want to take sides in that way. I know most people that run YouTube channels use Amazon affiliate links, so I feel like Amazon's a relatively neutral third party, so it doesn't affect people's opinions too much. But Bamboo Lab only sells their printers on their own website, so you can't even provide Amazon affiliate links for them. So yeah, we'll see. We will see. Crap. I forgot about one thing that I was messing up last time I was filming this, and that is we got a little fastener over here that didn't get seated properly because I was not following the correct order of assembly. let's fix that. This is a bad idea, but I'm full of bad ideas at this point. However, speaking of like Bamboo Lab and their affiliate / advertisement stuff, they did sponsor a video for Short Circuit, which is the Linus Tech Tips video channel. And I am curious how much they paid them to do a unboxing video on the P1P. Because I know Linus Media Group does not do free work. They're not like us little YouTube 3D printer content creator rats that basically work for free. So, how much money changed hands there? Who knows? Probably in the thousands. I mean, definitely in the thousands. Maybe 10,000, 20,000. I mean, they're moving a lot of printers by putting a advertisement on Linus Tech Tips. And they had that guy on the channel being like, "Oh my gosh, it's so good." I wish this video wasn't sponsored. Ugh. Looks like I need to use a longer screw for that one, so we'll bump up the size. I think maybe 18 millimeter. We'll try 18. Maybe 16. You know what? I don't need this bottom screw. That's unnecessary additional fasteners. 2 screws is enough to hold this in place. So that's what we're going with. Alright, let's catch up with the comments here. What brand again, Nathan builds robots? I'm pretty sure someone will come up with a similar solution for the K1. Super neat. Noctua is undoubtedly the best, but dealing with different voltages is stressful and I don't like stepping up or down. So that's how you got a lot of fans. Yep, I mean, this is my fan box. I've got a lot of fans there. Came to see Nathan build a robot, was not disappointed. Well, thank you. I am definitely going to be building this robot for the next hour or 3. I have a blower fan. I don't know where I got it. Probably from a laptop. The brand is 24 volts. Stepping voltage up or down is not a problem, but for the heated bed it is. Yeah, I agree with that. What's the draw for the V-Minion style printers besides the small footprint? It's just fun to build. So, I mean, building printers is kind of a hobby. So, it's not really a reasonable thing for most people to do. But if you just like building stuff and learning how things work, then I think a kit printer would be a good fit for you. Also, the V-Minion is very sturdy for how small it is. You know, it's got this cantilever construction, but it's quite sturdy. I won't say it's the sturdiest thing in the world, just because it's only got one arm supporting everything, and like looking at this, I can actually wobble this quite a bit, but I mean, it's pretty good. It's good enough for a small printer that's, you know, light, fun to put together. I mean, if you don't enjoy this assembly process, then I definitely wouldn't recommend it, just because it takes so long. But if you just want something to put together, like a fun little project, then this could be a good option for you. Okay, so I need to wire this into here. So let's go. I'll just cut off the end of this low noise adapter. Actually, I don't know if that's a good idea. I'll use the extension cord just so I have some extra. Oh, wait, here we go. We've got this. This is the other thing that you get with Noctua fans. So since I bought the Noctua fan, it comes with all of these great little accessories. So we got our 2 low noise adapters, which I'm using here. And it also comes with this Omni join cable. And this is actually what inspired me to put together my little kit for solderless fan connections. This is something that Noctua came up with, where they give you 2 of these little connectors. These are common connectors that were always used in the telecommunications industry for the longest time. And you just, like for putting, wiring up telephone wires, they were always used for that. So we'll just get that. I'll plug in, I'll make sure I'm using the right wire here for the right job. But it looks like I gotta do some cross-referencing just to make sure I'm plugging the positive and negative in correctly. But it looks like the opposite of the white stripy cable is here. Alright, so the opposite of the white stripy cable, when I follow the wires, is on the top left. Oof. Okay, so that's the positive end. So opposite is the positive. That makes sense. So I'll take this wire. This is the positive wire, and I'll wire it up to this red piece for the little thing that comes in the box with that Noctua fan. So plug that in, pinch it, here we go. And then the opposite wire I'll wire up to the black plug. Alright, get that in there, give them a little pinch. Okay, so that all that wiring should be complete, and now I can just plug this in. You know, I've got my chain of little adapters and such. But we've got our Noctua fan, we've got our 2 low noise adapters, we've got our adapter plug, and we just plug all this in together, and then the Noctua fan works. So I know people have been saying, oh, I wish there was an easier way to plug Noctua fans in. But if you buy that 3-pin Noctua fan, then it comes with the low noise adapters and this adapter kit. Just verify that those contents are in the box. Usually they'll say, here's what's included in the kit. And if you have all of those and just plug them in together, then you can get it to work without too much issues. Alright, so I'll just fold all of this up into a little area. It is a little bit annoying how much extra cable length I have here to manage, but we'll figure out what to do with it. I don't like having all this extra stuff on the tool head, so maybe I'll just split these up a little bit and pull it into the wiring harness. So here goes. Yeah, I'll just separate these 2 wires. And then recess the one with the Noctua cable further down into this harness. And actually, I'm going to do away with this little cable shield here. And I'm going to cut a longer one out so that everything is nice and contained in there. Okay, so let's get everything all nice and tidied up now. So just pull all these wires Alright, so I got all these wires pulled. Alright, so wires are all controlled here, and now I'm just going to pull all the slack out of them and get them running all down here. I'll put a couple of zip ties on this bundle of wires as we move our way down. Finally, we're cleaning up this cable wiring. Hopefully there's no faults in this wiring because I'm just going for it. If there's a mistake in here, it'll be kind of annoying to address now because it's all getting bundled up. But I gotta do it eventually, so let's just do it. Hello world, hello Eskander X. 9th year anniversary. Oh yeah, that's right. They're competing with me. Xenon, you just said that and like everybody left to go watch Creality's live stream. Let me know if anything interesting's happening over there. Just pop open a second tab and keep tabs on them, so to speak. They're probably doing some giveaway or something. I don't really know what they have planned. But yeah, 9 years of Creality producing 3D printers. Cool stuff. Kit building is a good draw. I'm looking to do a switch wire conversion. Yeah, I like a lot of my other printers. I start out with a working 3D printer and then I add modifications to it to get it to kind of more suit my needs. And I never have really been drawn to a kit printer because I feel like they're kind of expensive, and if you don't know exactly what you want and you can't specify the kit and build it out the way that you want, you don't know enough about the components, then it doesn't really make sense. And it's not really saving you any money. It's kind of an expensive way to build a printer, very time consuming. So it's not for everyone. I'm going to put a little zip tie into this connector just to hold it closed. And I'll do this with all the connectors that are in the harness. I'm just putting a little zip tie around them and making sure they don't come unplugged while I'm printing. Not sure if this is actually a good idea, but if something comes unplugged while I'm printing, that's going to suck. So this is the way I'm doing it. You could just use a dab of hot glue or tape to keep these from coming apart. But I've got zip ties handy, so I'm using the zip ties. Alright, so let's trim all this up. Anyone got any news on that 9th anniversary Creality live stream? Oh yeah, they're also sending me, Creality's sending me all their latest stuff. It's kind of cool. I'm going to be getting a resin printer from them. So my first resin printer on the channel will be the Creality, I don't know what it's called, but it's like a 8K massive printer. So that's going to be pretty neat. I've had a couple other companies approach me and ask if I could review one of their printers for them, like their resin printers. But they're trying to send me like their cheapest garbage printer that's just not going to be fun to use, so I decided to just save myself the headache and decline those opportunities. But, you know, Creality's sending me the good shit, so I'm going to go ahead and use it. So any other companies out there thinking about sending me stuff, just send me the good stuff and I will do a review on it. If you send me like an $80 printer, then I'm probably not going to want to have anything to do with it. Just because of how much time it takes to set those printers up, and usually the cheaper ones have worse quality control, so it just ends up wasting a lot of time. Alright. I'm probably putting way too many zip ties in here, but oh well. I'll put like 2 more, and then I'll wrap it up in that that white cable housing that I have. Alright, and I'll zip tie this connector so it doesn't come loose. Oops, just unplugged it. That's what we're trying to avoid here. Ah. You don't envy me for getting the first revision. Well, we'll see. I mean, the pros of that situation is I get the engineering review units that have been kind of built and tested by their team of engineers. So hopefully they've worked out any build quality issues. However, it'll have all the bugs that the first generation machines will come with. So we'll see how many bugs there are. Hopefully it won't be too bad, but I would not be surprised if there's some kind of initial quality control issues with the first machines coming out. That's pretty common across all industries for that to happen. And when you're dealing with 3D printers, it's especially bad. Alright, so we got that all done. Now time to add some of this pretty white cable management stuff. I like this. It just looks really nice and it fits the build well. So you always want to cut out a little bit more than you need because it's harder to basically shrink it up. I mean, it's always easier to just cut a little bit more off than to make the cable wrap longer. So I'm going to get a pair of scissors and see if I can make a clean cut here. Last time I didn't do a very good job at cutting it, but I'm going to have to pay a little more attention this time. So on the ends, I'll just practice here. So I'll cut. I think the best way to cut it is probably just to get it to fold flat like this, and then just cut it just like that. And then give it a little bit of fire to clean up the edges. There we go. That looks pretty good. So I'll do the same thing for the other end. So just splay it out like this. Get it to be relatively flat, and then cut it. And then splay it out and give it some fire. All right, and then we'll wrap it all up. All right, more cable. I'll put one more zip tie down here just to kind of keep everything from being a complete mess. Looks like we've got a bunch of extra cable length for the probe here, the Z probe, so I'm just going to tuck that into here just to kind of put it away somewhere. All right, and that's pretty good. All right, and if I can get a zip tie around the top here, I think that'll kind of hold everything together. It'd be ideal if I could rotate this. Might look a little bit better. All right, there we go. Wrap it up, give it a little twist, and then think I need to use a couple of zip ties around the outside of this cable wrap. Just because, I don't know, there's some weird stuff going on in there, so. Their format and audio quality is complete shit. Alright. Well, good to know that my little home studio is doing better than Creality's production value. Alright, so I think maybe we put this in here. Okay, that's looking good. Yeah, Creality should leave the content creation to the content creators. Something about corporations hosting events like this never tends to go as well as they think it will. So I guess I'll just put zip ties at like little fixed distances here. It's gonna look a little bit weird, but maybe it's its own style. Little umbilical cord looking thing. Well, hey, drop a comment or a like if you think I should host the next Creality live stream. Let me just do the whole thing. I'm sure it'll be a heck of a show. Alright, 2 more and I think that'll finish up this little harness. I mean, hopefully this works out. It's looking a little sketchy, but yeah. Alright, that's looking pretty good. I'll say my wiring is 90% complete at this point. I think it's all plugged in actually. Trying to think if there's anything I left out. We've got everything on the Hotend wired up. I've got the heated bed wired up. Got my power source ready. I completely skipped the bed leveling the end stops. So I'll be missing that. Got all my stepper motors plugged in. I think I'm ready to power this thing up and see what happens. Yeah. So, wish me luck on that part. We're gonna need a Easter miracle to make sure that this turns out right. Ooh, Ooh, I guess I can tuck this wire into the harness too. The stepper motor wire. I just sneak it in there. I don't think anyone responded to my pleas for help setting up UART communication, so we'll just see what happens when I plug this in. And it'll probably take me another 20 minutes to just mess around with things to get that set up and running. But that's not that big of a deal. Alright, now we got our stepper motor running into that, into this umbilical. So it's all looking pretty good. We're almost ready to fire this thing up. Sweet. Alright, so firmware time. I'm going to be using RatOS, like the greasy rat I am. Let's catch up with the chat. It looks like we've got some comments. I think everyone's showing my support for a one of those Creality live streams. I would love to host that, just to troll them a little bit. But the way corporations are, I think they tend to be a little more risk averse. So having a loose cannon up on stage might not be a good idea for them. There's cake at the end. Oh, dang. I don't have cake right now, but maybe I'll order some. 3D printers need to look into Oliflex wiring setups. Their high flex wires are designed for moving assemblies. Wow, James, you sound like a salesman. Their high flex wires are designed for moving assemblies. Have you done any new mods to the Flying Bear? No, I fried it. It's the frying bear, as someone else told me. I would like to just fix it and get it working and then probably sell it. It's not the most moddable design setup. It's kind of like with Ender 3s and such, you've got a lot of ways to upgrade them, but that one's just designed to be, that flying bear is just kind of designed to be its own thing. Pretty good design. Okay, so let's see how this works. If I put this, on here. Okay. If I put this lid on, let's see how it looks. It's not easy managing this mess of wires, but we'll get it. I feel like my Hotend wires are a little bit shorter than they need to be, so it's making this closing this up a little more difficult. So this is the hideous mess of wires I'm trying to contain here. Hold on, I just got a food delivery, so I'm gonna go grab that. Be back in, let's see, give me 1 minute. Alright, sorry about the delay there. I just got lunch. So that means I'm going to be able to stream for 12 hours straight. We got the nutrition we need. A little rice bowl with some goodies. So, alright. Anyways, we're trying to manage this wiring mess. And also, I need to set up... what did I need to set up? Oh yeah, RatOS. So let's get our RatOS going. Sorry, I didn't get enough food to share, so... Alright. So, it's time for RatOS. I'm not sure what that means, but we're going to find out. So, here we go, RatOS. Now, I'm not sure what kind of printer I have, which one of these I need, but basically, if we go to the RatOS website, they say you have to flash your Raspberry Pi, something. So there's a bunch of these different like images. I'm not sure which one I need. I'm using a Raspberry Pi 3 Model B V1.2. So let me just look that up. Raspberry Pi 3B 1.2. Let's look up the specs there. So, according to Raspberry Pi, we are running 64-bit CPU. So, back over here. That means we probably need the 64-bit. I'm not sure what any of this stuff means. I think I just need this one. Yeah, that seems right. So, anyways, I download that. And what else do I do? The firmware guide is available here. All right. Okay, there's nothing here except it tells you go here. All right. Documentation. All right. Okay, here we go again. This is one of those clipper things that's always going to take forever to set up and figure out. So, great. All right. So, how do I get started? Supposedly this is supposed to make things easier. Oh, I'll be the judge of that. So download the latest release and use Balena Etcher to write that image to an SD card. Okay. Let's do Balena Etcher. Okay. I'm on Mac. Etcher for Mac OS. Yeah, I think this is the one. So we're downloading. And if you'll excuse me while I look in my downloads folder, make sure there's nothing sus in there. And I'll just make sure everything's all clear, and we'll get the screen back up. Okay. Okay, now I've got Balena Etcher, and I guess I need to put that on an SD card. So, all right, there's my delicious lunch, and where's my SD card? I already pulled it out of the Raspberry Pi so I can install some stuff onto it. And I have the technology to flash an SD card. Okay, here's our SD card, and I've got a little SD card reader, so just gotta find that. Oh, there it is. Of course, I dropped it on the floor earlier. So, plug that in and use Balena Etcher to put that on there. Okay, it shouldn't be that hard. This is the hard part, you know, plugging it into the computer. Okay. And, all right, now we're getting to the fun part. So, Balena Etcher, where are you? Come on, where is it? I guess it's opening. It might take a while. Yeah, it's just opening, so. Flash from file. All right, select target. So yeah, I've selected the image that I just downloaded. Select the target, SanDisk Media, and Flash. So that's going to delete all the old stuff that I had on there. I'm going to type my password. It's probably something I should do off to the side. Unless you think the password's a useful thing for you to know. Okay, and yes, we are giving Balena access to the entire mainframe. Alright, and apparently that's going to take 5 minutes. So this is a great time to read through the comments and see what's going on over here. Oh yeah, these aren't asparagus, this is green beans. Yeah, Creality is a good printer. I have a 5S1, but watching market move to proprietary designs means less fun for modders. Yeah, that K1 looks like it's going to be pretty difficult to modify. But once I get my hands on one, I'll take it apart and see what we can do. I feel like Derek Cirillo is begging me to plug my new breakout board. Actually, it's kind of an old design at this point. The modder board for my, basically, I'll just go to my website. If you just Google modder board, this is my little product I've been developing. Basically, you just plug this onto your 24-pin connector Ender 3 S1 or Ender 5 S1, and it's got all the old connectors that you had on your old breakout board, but I also put a bunch of new connectors that are kind of like the old style, and that just helps you install whatever kind of stuff you want. So instead of being locked into using these tiny little connectors that have all sorts of issues with breaking and stuff, we got these nice connectors up top that are just the standard ones that we're used to. So if you want to check that out, just go to nathansellsrobots.com. My other domain is nathanbuildsrobots, but since I'm selling something here, I figure I should probably change that to nathansellsrobots. Oh yeah, excellent idea of adding the QR code on the board. Yeah, that just takes you to a website with some links to some videos and instructions, which helps you get started. On my first editions of the board, I was experimenting with the QR codes being made out of gold, which was pretty fun, but I think, I think just having it in white paint on black makes it easier to read. Yeah, I would go to Creality's live stream and check it out, but I'm worried about the copyright stuff. And it's probably fair use because I'll be commenting on all the bullshit that's going on, but I figure it's easier to just avoid that mess entirely. I had one issue with copyright on one of my videos, and it was pretty easy to clear up, but it's a little annoying to deal with. So that's why I pretty much only use my own content when I'm making videos. It just solves a lot of those issues. So when I talked to Creality, they said the K1 Plus, or the K1 Max, was supposed to be faster than the K1, which I don't know if that's true. I guess it has the LiDAR module, versus the regular K1 doesn't have the LiDAR, just looking at these two side by side. This one also has an AI camera, and the other one doesn't claim to have that. So maybe the K1 is just like a smarter, faster printer. One thing that I noticed is that on the P1P, the P1P doesn't have a cable chain versus the X1 Carbon does have the cable chain. And if you try to buy and install the cable chain onto the P1P, Bamboo Labs' website actually recommends against doing that because it can damage the cable. So that's a little disappointing to see that you can't add that upgrade to the P1P. But yeah, let's just look at the construction of this a little bit better. I'm going to switch over to my, my screen capture so you can see. I want to do a little bit of analysis on what we have here so far. And maybe I'll follow this up with doing a full video on my channel. Just what we know so far about the K1. But it looks like injection molded parts for this top front and back left. And these might be die cast. I can't really tell from this image. And it looks like aluminum extrusion here. These back left and front left pieces. I mean, these might be machined or they might be injection molded. I would guess that all of this stuff that is not the aluminum extrusions is going to be injection molded, just because that's typically cheaper to manufacture. But I'm hoping this will be a lot more serviceable than the P1P, because the P1P you can't really take it apart. This is a little interesting. No, I'm misreading this here. But I mean, look at the size of these stepper motors. These are absolutely massive. These are like 50% larger. They're like double the size of what you find on a normal Creality machine, and they're like 50% larger than what's on the P1P. So, I mean, you might be able to unlock faster speeds with that. The bigger motors will be able to produce more torque, and they kind of balance that out by using larger stepper motor pulleys here. So that gives you a higher gear ratio, or I guess a lower gear ratio. It gives you the ability to reach higher speeds. So I would actually believe it when they say that this printer can print faster than the P1P, just because the motors are bigger and those pulleys are bigger. King Sideraki says, had to put all the old connectors on a new section at the top due to the QR code. Oh, that's not entirely true. That whole middle section has to be empty because the way Creality designed that breakout board, that whole area is sandwiched between two parts, so you can't really put any components there. LiDAR, I thought the Bamboo Lab had patented the use of the LiDAR for calibrations. I'm not sure. Do you think Creality cares about patents? I mean, it doesn't seem like Creality's really patented anything. And okay, so it looks like our flashing is successful. So I'm going to plug that into the SD card reader for my my Raspberry Pi. I'll make sure to let's see. Always got to make sure to eject things properly so we don't corrupt our data. But let's switch back to camera. Boom. So let's see. I just need to eject. All right. And that should be good. Oh, and this SD card is hot, so it was doing something. All right. So we'll just plug this into the SD card reader. And I'm not sure what's supposed to happen here. I'm not sure if it would be easier to just run regular Clipper instead of RatOS, but RatOS should be interesting to check out. All right, I gotta eat a little bit. So in the meantime, I'm gonna show you a video. One of my previous videos where I set up sensorless homing. So maybe I'll figure out how to do sensorless homing by watching this video. That's the real advantage to publishing YouTube videos, is you have like a record of all the projects that you've done. So if you need to go back and do the same thing, you can always just open that up and copy your old work. Now, for all of you who haven't seen this video, I'm a little bit disappointed in you, but I'll forgive you. But I think it's one of my best reviews and videos to date. So take that for what it's worth. I'm not sure if I set up sensorless homing on this build or not, but let's just watch it and find out. So tell me if you can hear this on stream. This episode of Pimp My Printer. I heard you like fans. So last episode I put fans on your fans so you can help keep your printer even cooler. We ended up with 6. Are you guys able to hear that? Let's see what the chat is saying. RatOS comes pre-configured, but it's pretty much vanilla Clipper. Okay, just copy the CFGs. Sounds good. Okay, James is saying you can hear it. So I think I set up sensorless homing on this build. What's better than 6 fans? 8 fans? 10 fans? 100 fans? How about 0 fans? After all, the quietest fan is no fan at all. If we put big enough heat sinks on here, we won't even need fans. So let's check this thing out. I put a CPU heatsink on the hot end, as well as some LEDs to make this thing look as much like a UFO as possible. It's basically a V6 style hot end, except I made it out of a CPU heatsink in my backyard using a hand drill, which was pretty challenging. I replaced the main board with a Big Tree Tech SKR Mini. This will allow for the quietest stepper operation and enhanced cooling. I put heat sinks and a vapor chamber on the main board to help keep the stepper drivers cool. And while I was at it, I put a volcano hot end and a direct drag dual gear extruder on there, because why not? I'm using a titanium all metal heat break, so we'll see how that works out for us. And I got rid of that old dumpy power supply and replaced it with a 330 watt Dell. Oh crap. You guys can't see the video. Okay, hold on. You missed out on a lot of good visuals. Let me just restart. That's just a minute into the video, so hopefully. What's up, my printer people? Welcome to this episode of Pimp My Printer. I heard you like fans. So last episode I put fans on your fans so you can help keep your printer even cooler. We ended up with 6 fans in total. What's better than 6 fans? 8 fans? 10 fans? 100 fans? How about 0 fans? After all, the quietest fan is no fan at all. If we put big enough heat sinks on here, we won't even need fans. So let's check this thing out. I put a CPU heatsink on the hot end, as well as some LEDs to make this thing look as much like a UFO as possible. It's basically a V6 style hot end, except I made it out of a CPU heatsink in my backyard using a hand drill, which was pretty challenging. I replaced the main board with a Big Tree Tech SKR Mini. This will allow for the quietest stepper operation and enhanced cooling. I put heat sinks and a vapor chamber on the main board to help keep the stepper drivers cool. And while I was at it, I put a volcano hot end and a direct drag dual gear extruder on there, because why not? I'm using a titanium all metal heat break, so we'll see how that works out for us. And I got rid of that old dumpy power supply and replaced it with a 330 watt Dell laptop power. So I'm actually using this power supply on this build. I'm reusing that little bit just because it's a really nice power supply and it should be nice and quiet. The best thing about this power supply is that it has no fan, so it fits right in with the rest of the build. Okay, so this was using a SKR Mini E3, which doesn't have removable stepper drivers, so I'm not sure how the jumper situation needs to be on this new one. Yep. I was putting thermal paste on everything even back in the day. And I'm really surprised I didn't slice my hands open doing this, because it felt really dangerous. Alright, and here it is fully installed. Wiring this up was actually really simple because I only have wires going to the hot end. I printer's been running for about an hour, and it looks like I'm having some problems with the bed sheet. If I look at the heatsink, it's running about 52 degrees Celsius, which is pretty hot. Interesting, so it looks like the heatsink is working a lot more effectively now that we're raised off of the heated build tray. The temperature has dropped to about 46 degrees Celsius. Looks pretty nice. I think part of the reason I couldn't get the bedsheet to print is the heatsink is actually soaking up a lot of the heat from the heated bed when it's close to it like this. It's getting radiative and convective heat transfer. By the time it moves up off the build tray, it's got a little more distance there, and it's able to cool more effectively. I just got these LED rings in the mail, and after you see this thing turned on, you're going to be super impressed with it. So here we go. So that's a ton of light. When I looked at the analytics for this video, a lot of people tuned off at this point because they were like, why is this guy shilling these LED lights? But I bought these and I just thought they were cool, so I just wanted to share it. The button changes the speed of the pattern that's playing. If you press up or down, you change the effect. On the white LED setting, which draws the most power, it's actually running into the current limit at 5 amps. So this is over 25 watts of LED light, and it's incredibly bright. That loud fan noise is coming from my power supply. It's having trouble pushing all this current. But let's look at a few more settings before I show you how I'm going to put this on the 3D printer. Wow. This little LED driver can also control strip lights, so I really want to get a couple more of these to use on other projects. As cool as this thing is when it's all in one big circle like this, I want to break it into these smaller ring segments so that I can incorporate them onto my projects more easily. Installing the ring light was pretty simple. All I had to do is cut the ring so that it's more like a split ring, and this way I can take it on and off without having to disassemble the printer. If you're going to cut a slit in one of these rings, it's important to do it in just the right spot. If I cut it on the data input side, the data would come into this ring and start going this way, and it'd get interrupted right there. But since I cut it on this side, the data comes in, it goes all the way around the circle, and then it reaches the end over here. So it's really important to know where you're cutting it so that you don't disable your whole ring light. And when it's all put together, I'm left with this mesmerizing RGB LED display. The way it bounces off the heatsink spins and mixes the colors looks really awesome. These LED lights don't help keep the heatsink cool, but they help it look cool, which is more important. Before I put this thing together for the last time, I'm going to upgrade the entire Hotend to a new version. This Hotend uses a cartridge-style thermistor, which is much better than the glass bead style thermistor. Because, I don't know if you can see it, but on this glass bead style thermistor, it has little exposed wires down there. And those wires, if they make contact with the heater block, they can short out, and it can really cause some damage. If 24 volts touches the heater block or the heatsink, then it'll instantly short to this thermistor and blow up your microprocessor. And that means you'll have to buy a completely new mainboard. Ask me how I know. Also, I'll be using a 60 watt heater cartridge since I'm running at 19.5 volts. If we do the math, this 24 volt. Yeah, so that's the other thing with this Dell laptop power supply I'm using. It's just under 20 volts. So it's not technically the right voltage for this machine. Oh yeah, so that should make the fans run slower and the heater elements heat up slower. But it's close enough that it works okay. 60 watt heater cartridge has almost exactly 40 watts of output when I'm running it on 19.5 volts. So this means I'll have the exact same performance even though I'm running at a lower voltage. This is actually a really neat way to visualize the airflow and see how the heatsink is keeping things cool. There's a stream of smoke heading straight up and away from the heatsink. That's the natural convection in action. The Volcano Hotend is known for being able to increase printing speed and put down a lot more plastic, which makes you think that it's kind of a hotter device. But ironically, it's actually keeping the machine cooler because it has less top surface area. And that top surface area transfers heat directly into the heatsink. By having a smaller top surface area, the Volcano actually keeps things a little bit cooler. So let's get to the printing. We'll start with a 200% scale benchy and then do some easier printing. I realize what the weak point is in terms of the silence of this machine.
spool is making too much noise. Way too loud. So I gotta print out a new spool holder that'll be a little bit quieter. Every time the filament rustles, it jumps up to 44 to 50 decibels. Let's jump back to thermal vision and see how our heatsink's doing. We're seeing, 34, 38 degrees, kind of the maximum temperature. So it's staying really cool. I have no doubts that this is performing just as well as the stock heater, except zero fan noise.
Yeah, the fog machine is nice. That was just like some oil burning off of the hot end.
If you look at the stepper drivers and the CPU and all that stuff, it's about 26 degrees Celsius. So no thermal problems there at all. And if we look on the back side, the vapor chamber is doing a wonderful job of keeping things cool. It's bringing that heat away from the motherboard so it can be dissipated with natural convection. Unfortunately, this is where the benchy starts to fall apart. It's not able to print this overhang on the bow of the ship because it's not able to cool it off enough. So it starts curling up and eventually it results in a failed print.
That's a bad benchy.
I could let this finish producing a crappy benchy, but I think I'm going to end the test here and print something that's more representative of the kind of bland, functional designs that I normally produce. Just to give you a sense of how quiet this machine is, I've set it up with a window open in the background. I live in a typical residential neighborhood with cars driving around and birds chirping and stuff. And the window's about 5 meters away. The printer's about 1 meter away. So why don't you just take a listen and judge for yourself.
Yeah, so that's my 33 decibel printer. I mean, that's basically, the only noise was coming from just like ambient noise from the vents in my house operating. So, I mean, this is an extremely quiet build. And you can see up here, this little end stop right there. I installed that because it had sensorless homing, so it just bumps up against that and then it just works.
So it's extremely cool. In fact, these temperatures are lower than the stock heatsink. So we're not sacrificing any cooling performance.
And I also added some stepper motor heat sinks and some isolators here, and those helped keep the stepper motors even quieter. So, I mean, you can make a 3D printer extremely quiet. Alright, you ready for the conclusion of the video? Let's see it.
So, what do you think of this hot end? Have I gone too far in the pursuit of silence? Let me know in the comments below. So, overall, I think fanless 3D printers are pretty awesome. They have a number of advantages, including added safety, because you'll never have a meltdown due to a failed fan, reduced noise, and, come on, this thing just looks awesome. So this is Nathan Builds Robots signing out, and I'll see you in the next episode.
Alright, there you go. I think that was also my face reveal, so that was my first time on camera. So, you know, this video, it was my masterpiece. I made it a long time ago, and it only has 4,000 views. I feel like if I reposted this video today, it would probably get like 10K, right? Like in a couple weeks. But whatever. I misspelled quietest in the thumbnail. I probably didn't bother fixing that. But alright, so now I need to do some research on how to do sensorless homing. I thought that would be the solution that I needed. But from what I recall, there's something I need to do to these little things to get them set up properly. So let's go to the Big Tree Tech website and see how to set this stuff up. So ETT TMC 2209 what's it called? UART mode. That's right. So let's see what they say here. Problem is, see, this is where things get confusing because, like, there's all these jumpers and stuff. Okay, sorry about that. So there's all these jumpers and stuff, and you have to figure out like what pins to put on there. Let's see. UART, 5th pin is used as the UART. I don't even know what that means. CFG pins or UART. Yes, I would like UART, please. Is it set up for UART by default? Like, it told me to unplug some jumpers. Damn, birds chirping. Gotta move to Chernobyl to get rid of the bird noise. Yeah. Is your end stop based on current sense? Yeah, it should. I would like it to be. I'm not sure how to set that up, though. That's what I'm trying to figure out right now. I think UART stands for that. I'm not sure. Okay, so let's just see what we got here. Maybe I need to get some of these LDO motors. These are supposed to be pretty good. But right now I'm just using Creality basic stepper motors that are supposed to be used for extruders. Okay. So I'm actually going to pull this into another window and watch it on mute so I don't get in copyright trouble, unless I want to try and fair use it and provide some commentary to his video. I'm getting an ad on YouTube for the BQ H2 extruder. Okay, so I'm just going to jump around and see how he set up his jumpers. No pun intended. I'm just going to give it a try and see. I'm just going to power it up and see what happens. Because it might have been set up. Let me just go back to live view. Boop. Okay. So that whole procedure that I had to do while assembling this, where it had me pull a bunch of these jumper cables out, that might have been setting up the UART, so maybe UART's already set up here and I'm good to go. So I'm just going to go off of that assumption, which is probably a bad assumption, but we got to get on with the build. Also, I haven't powered this up before, so we'll see what happens. It might just burst into flames. So yeah, let's just give it a try. So, first thing I'm going to do is check the power supply polarity, just to make sure I'm not plugging it in backwards. And I need to get a one of those little plugs for turning on the power supply. So I'll be right back. Just got to get a cable. Should take like 20 seconds. So I'm just going to plug in the power supply and see what we get. So I'm going to plug this in. And I'll just make sure that I respected the standard positive and negative wiring on these things. It's always good to verify. So this should be positive and this should be negative. That's backwards to what I was thinking. But that might be right still. Let's see. Oh no, that's right. I wired this up correctly. So just like this, I've got 19.7 volts showing up. Hello, autofocus. All right, 19.7 volts with the kind of triangular shaped lead being the negative. So I'm ready to plug this in. I'm just going to clean up my desk just a little bit before we light this thing on fire due to improper wiring. Alright, maybe Nathan's using a different time scale. Oh yeah, that was longer than 20 seconds. You know what they say about time, though? It's all relative. UART mode jumper scheme is on the back of the board if you want to double check. Well, the board is the board is on like I bolted it down to the base here. If it's on the back of one of these breakout boards, I have that. Not sure what this all means. On the back of this board. Not much information there. I'm just going to assume that it's set up for UART and we'll see what happens. But I'm ready to plug this thing in. Wish me luck. You all ready for this? Here comes the big reveal. Let's just zoom in on this mess of power supply cables in case anything blows up. All right. All right, there we go. Not a whole lot of issues there. Here's our Raspberry Pi. There's our main board. I don't have a main board fan set up on this yet, or I also don't have the little stepper motor driver heat sinks on there, because I feel like they're probably going to get knocked off by all these random cables I have going everywhere. So I'm going to need to sort out my cable management. So let's go ahead and do that. But no smoke yet. That's a good thing. I guess I need to SSH into this or something. So we'll do that shortly. All right. Come on, cables. Cable management is always the worst part. Objectively the worst part of building a 3D printer or a computer. Alright, so yeah, I need to put a fan on here and all sorts of other stuff. Also, I should probably put this fan duct on right here so we have part cooling. But let's get everything working first. I mean, if I can home this printer, then that's going to be a good start. So, let's see. what do I do now? So I'll go to the Ratrig website, try and figure this out. So installing RatOS, I think I've installed it now. Now I go to RatOS local. Oh shoot! Well, I mean, this thing has no way of getting on my internet because I didn't put in my Wi-Fi password or anything. So RatOS local isn't working. Wi-Fi or Ethernet? Well, Wi-Fi. Okay. All right. You can use an Ethernet cable. Okay, well, I don't want to do that. The Raspberry Pi will host a local hotspot called RatOS. Okay, join this hotspot on your phone or PC laptop with Wi-Fi. When connected, open up. Okay, all right. So it says here, basically to join the hotspot that's hosted on RatOS. So I'll do that. Oh, cool. Yeah, there's a RatOS hotspot. I'm logging into it now. I'm not sure. Their password is Raspberry. Back on stream. Okay. So that wasn't a good idea, what I just did. I tried to join the Raspberry Pi's Wi-Fi, but I forgot that knocks my my stream offline because I don't have internet when I log into the hotspot there. So what I'm gonna do is log into that network using my cell phone. My Hotend wiring is only held together by rubber bands because I'm out of zip ties. Well, that's not good. Hiring a blind cable manager is a good idea. I don't know about that. I mean, if I could run all the wires in, let's see. If I could run all the wires into this hole here, that would be, hold on. Yeah, if I could run all the wires into this hole here, that'd be pretty nice. But it looks like there's, that's not going to be as easy as I would like because I'd have to rerun all the cables. But yeah, that's going to be the best solution. I'll set that up a little bit later. Maybe I'll run some more cable down there. Yeah, that'll work just fine. The thing is that I have to unplug each cable and run it through that hole one by one, unless I melted a little hole in the top here. I think that'd be fine. Okay, so put blue sleeving on it and chroma key it out and replace it with something tidy. Yeah. Alright, well anyways, I'm going to log into this Raspberry Pi hotspot and see if I can set up the Wi-Fi information so it can get on my local network. Joni Mitchell, we'll see about that. Yeah, nice. I'll watch some of those Joni Mitchell videos a little later. Those will definitely give me a copyright strike. Dang music industry. You're prototyping, make it so the works and then dress it up later. Yeah, that's a good idea. Yeah, no need to overly optimize the wiring right now. So let's see. Let's join that Wi-Fi hotspot and set up the thing. My iPhone is very slow at loading Wi-Fi networks, so this is taking a minute, and it's not showing everything. So this makes things a bit tricky now, doesn't it? Because if I can't do this on stream because my stream goes down when I try to log into the hotspot. So I'm gonna have to use another computer to get this going. Let me get another computer and I'll be right back. Okay, so I have to get another laptop going for this because if I do the setup the way that they're telling me to, I'll put it on screen for you so you can read along. It's saying to log into the Wi-Fi hotspot and then set up the network. So this is their way of basically getting rid of one of the annoying parts of setting up a Raspberry Pi onto your local network. Because you either have to put a little folder, like a little text file, onto the Raspberry Pi that tells you your Wi-Fi information. That's kind of annoying to do. And also, if you don't do that, then you can SSH onto the thing, and you know, there's always something you have to do that's kind of annoying to get these things on your Wi-Fi, since it doesn't have its own screen input or input-output or whatever. So yeah, we'll join the local network. We'll join that hotspot on my other computer. So please bear with me while I get this running. I'm firing up this second laptop, and it's a Mac. It's a Mac as well, so you know how these Macs are. They take forever. Yeah, do it on your phone. I tried. It wasn't showing up on my phone. I mean, that's kind of concerning. But anyways, I got this going on another laptop. So here we go. Raspberry. Okay, so now I've got this other computer, and I'm logged into the RatOS hotspot. Then I need to go to ratos.local/configure. ratos.local/configure. Okay, so now I have a handy little screen here. I'll show you what's going on. So here's our okay, so here's our, oh yeah, I don't want to show you all my Wi-Fi information, but basically I'm setting up the Wi-Fi right now. So I gotta look up my Wi-Fi password and pass it along to this little Raspberry Pi here. And then once that's all good, we'll be able to start doing some Clipper stuff. So I'll be right back. I'm just going to go check my Wi-Fi password and type it in here. Okay, so I just followed the guide and put in my Wi-Fi information. Now I guess this thing is restarting and logging on to my local Wi-Fi network. And that will let me do some stuff. Basically access this just like any other Clipper machine, like you're running a Sonic Pad or anything else Clipper related. So we'll give it a couple minutes to boot up, and then I'll log into that network and see what's going on. RatOS, I think, is just like a pre-configured Clipper. They explain it on their website here. I'm not sure. Let's see. Yeah, they explain it a little bit. So RatOS is a pre-configured Raspberry Pi image that makes things painless as possible. So, all right, now let's go to, I think we're ready for the next step here. So if we go to this website, we should be able to log into our little local machine here. See if it works. There we go. Oh no. Now I've got everybody's wireless network names. Well, that's not what I wanted. No, okay. I don't want to configure. I just want to go to this here. So, there we go. There we go. Okay, everything's working now. Let me just go put this other laptop away, and we'll be able to get going. $9.99, James? What's the K1's planned price? I think the K1's planned price is $5.99, and then the K1 Max is the more expensive one. It might be $9.99. I smell... Okay, right. So, looks like this is up and running. For some reason it's saying the Raspberry Pi is, it's heating up a little bit, I guess. Yep, that little processor feels pretty hot. We're running at 50 degrees Celsius on that Raspberry Pi processor there. So I probably need to put a fan on there or something. But let me put this laptop away and we'll go through the rest of the setup and see if we can get something printing. Okay, so Nathan turns to fans only for CPU. Yeah, well, I mean, I don't know how hot these can get before it like shuts down or whatever, but I'll get a little fan set up in there if it's necessary. So let's see. I guess I need to install the V-Minion config. Let me flip this over so you can see it. So this is our whole interface here. I think I want to install the V-Minion config. So we'll see what happens. Click that. I'm not sure what that's doing. Yeah, so I mean, we'll see if this RatOS ends up being an easier experience or not. So did anyone have some Easter ham? Not sure exactly what you're supposed to be eating on Easter, but ham seems popular. I had some fried fish on Friday, because, you know, fish fries. So, you know, I'm not sure what exactly is going on here. Hopefully this is installing the V-Minion config. It's all a mystery to me. Yeah, so it just, you know, it'd be nice if it told me how long it was going to take, but we got some blinky LEDs here. There's something I think is happening. The LEDs have been blinking. So, I mean, any minute now, I think our... oh yeah, there we go. Clipper error. MCU is unable to connect. Well, that's good. Maybe I'll just refresh the page here. Okay, Clipper reports error. Firmware restart? Maybe? Ooh, lamb. Delicious. Yeah, this is the day when rabbits poop eggs. I don't know about you, but I find the Easter Bunny to be pretty creepy. I was at the mall. Oh, autofocus is freaking out. I was at the mall and there was like a creepy Easter Bunny just sitting there in the darkness, like in a dark corner, with his full suit, just nobody around. It looked like he was about to murder somebody. So it was pretty unsettling. I don't know why we have that Easter Bunny dude hanging out. I can imagine, like, if I was a kid, I'd probably be scared of it. Like, just his cold, lifeless eyes. So while we're chilling here, I'm gonna try and manage these cables just a little bit. I think the best thing I can do is just cut this and stuff all the cables in through that hole. So yeah, don't talk to strangers on in weird bunny suits. I mean, this is supposed to make things easier, right? This isn't making things easier. Okay, I'll try that. Okay, well, Balu YT sounds like he knows what's going on. Either that or he's trolling me. So, oh, okay, here we go. So, yeah, I just clicked this little thing here, and then it lets me pick some stuff. So I must have just not finished setting this up. So I've got a Big Tree Tech SKR2. We have a Big Tree Tech SKR2, and if I look on the board, there's probably going to be some numbers on that processor, so let me take a look at it. It says STM32F429. So that'll be the 429 here. Looks good. Next, how do you want to flash the SKR to 429? I guess I have to flash manually via SD card. So compile firmware. Now I have to find another SD card here and flash my my firmware over to it. So let me just find another micro SD card and get that done. Let's get it taken care of. Yeah, this compilation is taking a while. I guess normally this kind of stuff takes a while though, so it's not a big deal. And I don't know where this is going to go. Maybe it'll download to my computer and then I'll be able to do the rest of the steps. Still at work, so I have to wait till home. Yeah, I was actually looking at the new Creality K1 stuff today. Was there a specific video that's going around? Maybe, I watched this one. It looked pretty boring. Let me know if this is the video, Wojeki. This is the one of the dude waking up at his desk and doing some random stuff. If there's another video, I'll check it out too. I mean, this is total fair use if I'm commenting on the things. So I'll just Google Creality K1 again, see if there's anything else up there. K1 Max, that's great. 300 by 300. Sweet. There's a bunch of articles coming out on it, so I don't know how they knew this stuff. Maybe Creality talked to them and set up something. I'm not sure how this stuff works. Okay, let's just look at Creality's Twitter page. So Halot Mage series. So this is they're going to be sending me one of these and one of these potentially. They haven't confirmed I'd get a K1 Max yet, but and one of these, the regular K1. Ooh, wow. That's crazy. They had a whole outdoor stage set up. I hope people are getting crazy drunk at this this whole event. All right. Well, that all kicked off like 8 hours ago, I guess. But yeah, I'm gonna get a Halot Mage, so I'll check this out as well. Ah, shoot, they're not giving me the Halo Mage Pro. What's the difference? 10K, 10 inch, 8K, and the Pro is faster. 170 millimeters per hour versus this one, it doesn't say. Ooh, I want the faster one. I need to complain to Creality for them to send me cooler stuff. I'm not sure how they make one faster than the other. Maybe it's just like a brighter light to expose the stuff. It's got a pretty large build volume, but it's got an incredibly high resolution. 8K is very fine resolution. Cool. So how does this one go faster? It says typical speed is 70 millimeters per hour. So, I mean, if you're printing something that's like 4 to 5 inches tall, that's going to take an hour or 2 hours. That's pretty impressive. Let's see how fast this one is. They probably aren't going to say. 1 to 5 seconds per layer. So let's just say 5 seconds per layer. Oh man, and then it doesn't tell you how. Doesn't tell you how thick each layer is. So yeah, I'm just gonna have to learn a lot about this stuff, and maybe I'll make a video about this and then be like, hey, send me the better one. We'll see how it goes. I mean, if it sucks, then I don't really see the need to get the more expensive one that sucks, but if it works pretty good, then I'd be interested in getting this bigger one. All right. So, yes, that's the price. I thought I was looking at the price earlier. So here's the K1 Max. You scroll down to the bottom. This one is $9.99. And then the K1, just the base K1, which is like a smaller, cheaper version, is $5.99. But they're both fully enclosed. I mean, at least by the pictures. Maybe they're going to sell the enclosure separately like Bamboo Lab has been doing. Who knows? Yeah, it does look like a Bamboo Lab clone. Hopefully this will be better, though, in terms of serviceability and upgradability. The Bamboo Lab is like, mine is glued together, so I couldn't replace components if I wanted to. Alright, so let's check back in with this little RatOS thing. Okay, there we go. It's ready. So download firmware. Firmware.bin. We'll drag and drop that onto my SD card. Drag and drop. All right, so we got our firmware. right here. Ta-da! Now I'll just plug that in down. And I'll just plug this into the this thing here. So first I'll unplug everything. I think you should power things off before you flash the firmware. So I'll put that in. Oh no, is this? I think that's right. This is sticking out a lot, but it's probably fine. Okay, I'll zoom all the way in. So yeah, it just seems like it's sticking out a lot, but normally that's like up against an enclosure, so it's just barely sticking out of the front of the printer. So we'll power this back on. I'm using the manual power plug hack. So we turn that on, and hopefully it'll flash the firmware, and then this thing will be ready to run some commands. Maybe we'll print some stuff. So I got some green Polyterra today. I've used this on a couple other prints, and the quality was coming out pretty good. So if it can come out with some good prints on this printer, then that'll be all good. Everyone will be happy. So I'm not sure how long it takes to flash the firmware. Oh yeah, cool. It's giving me updates here. So it says the control board is flashing. Pretty cool. Ah. Sorry about the autofocus. It's freaking out a little bit. Okay, so control board flashing. We'll give it a minute. Well, normally I'd be getting tired at this point in the stream, but we're just getting started. I just had my lunch. I'm ready. We're going to be able to do this. I don't know if this actually means that the control board is flashing right now. Oh, no, there we go. It's totally doing it. Okay. I'll just leave it alone until it's done. Okay, SKR detected. Proceed to next step. I must say, this is easier than the normal deal. So I don't have a tool board, so normally the tool board, I think, is referring to if you have a tool board set up like a separate PCB on the top here that has its own MCU, then that would be your tool board. I actually have one from Big Tree Tech. They sent one over to me, but I haven't installed it on anything yet. And on this one, I'm just going to run it with these wires, you know, the traditional tethered setup. It's going to be fine for me. So yeah, I'm not going to install any tool board. I think I just hit next because I'm not using one. So let's go next. Toolboard flashing. I don't need to. Okay, configure printer in main cell. Now that your control board is configured, you can connect your printer via main cell and start configuring and calibrating your printer. Okay, open main cell. All right, that wasn't too difficult. For some reason, I skipped a step or something and got a little confused there. But overall, pretty good user experience. And now we can see we've got some temperatures on everything. It says our extruder is, our extruder is that temperature, extruder and heater, nice and cool. SKR2 and Raspberry Pi, I can see the temperatures of these individual little mini computers that are running the 3D printer. So that's good to know about. All looks good to me. Okay, so yeah, the James Ocker's commenting on the K1, how the extruder, the filament bends 90 degrees at the last minute. Let's see if we can find a picture of it. That's what the Bamboo Lab printer does as well. It has that, oh yeah, here. I mean, if it would just slow down a little bit, it'd be easier to see what's going on, but it's just printing too fast. Yeah, I mean, that looks like about a 1 or 2 inch radius, 1 or 2 inch bend radius. That's doable, and I don't think it should cause too much issues. Especially on a direct drive dual gear extruder, it should be able to pull filament right past that. So I think we're ready to do something. So I'm probably going to have to, if I home the thing, well, let's just try running some commands. So I'm concerned that it's going to expect there to be a non-sensorless homing, but I don't have sensorless homing set up, I don't think. I think it's going to be expecting it's going to be expecting some homing switches to be triggered, so it'll just keep running and then it'll start grinding because it's expecting it to run into something. But let's just try some commands. So let's turn the fan on. There we go. Fan's spinning. Sweet. Alright, so that fan works. Let's try the controller fan. Probably works. I just need to enable sensorless homing, and hopefully that'll work. So to do that, I need to go to Machine, printer.cfg. So we're checking out printer.cfg here. Pull it up on the screen. So let's see. I want sensorless homing. So this looks decently commented. So let's look up sensorless. Okay, so sensorless homing. Beware, this requires manual tinkering and does not work if your XY stepper drivers have clipped diag pins. Well, I have no idea what that means. So hopefully I don't have clipped diag pins. It is strongly recommended to use physical end stops if you're a beginner. If you still wish to proceed, copy config/template/sensorless homing into the root directory and remove the comment this from the line below, then tune the settings in it until you have reliable homing. Okay, so delete that. And if you only want to run sensorless homing on a single axis, copy the corresponding blah. Well, I want it to run on both axes, so we're gonna use that. Here's a section on input shaper. I'm not going to use that right now. I think input shaper will come in a separate episode. Maybe I'll do a full review on this thing on my main on a real video, and we'll be able to check out all of those calibrations and get it going as fast as possible. But for now, I think we're just gonna try and get things going with sensorless homing and get a test print started with no input shaper. So let me read those instructions a little bit more clearly now. So let's see. Sensorless homing. Uh-oh, am I breaking things? I think I'm breaking things. Okay. So sensorless homing. Copy config/templates/sensorless homing.cfg to the root directory. Okay. Let's see if I can figure out how to do that. Config/templates/sensorless homing to the root directory. Do I hit back? Okay. How do I close this file? It's going to hit the X up here. Oh, okay. Save and close. And then I need to figure out how to do this root directory mumbo jumbo. Ah, okay. RatOS, templates, sensorless homing. So I want to, I guess I'll download that. No, wait, I want this one. Download, and then go back to the root directory. Let's go back somehow. Root. Oh yeah, here we go. There we go. Now we're at the root directory. And then I just drag and drop this. Okay, maybe that worked. So I'll do a firmware restart now. I think that's what I'm supposed to do here. Alright, it's meant for high performance. LDOs can cope that high amount. You need to comment out the physical sensor. Okay. Alright, thanks for that. I'll do that as soon as this loads back up. Alright, so machine, printer.cfg, physical. So we'll just physical. Okay, so I'll comment these out. And then save and close. And I'll actually go back to that. Let's see, printer.cfg, save and restart. All right, so I think we're ready to try homing. Here goes nothing. I'm just going to go into my over here. We'll go dashboard. I'll try homing. Let's try homing Z first. Oh, Clipper's freaking out now. I guess restart. I guess firmware restart. Okay, so we're up and running again. See if the fan turns on. Okay, we've got something working. That's good. I'll turn that fan off. Now, I want to adjust this Y and... Oh, jeez. I want to adjust my Z end stop first before I get started here because I think it's way too high initially. So let's adjust it. All right, so adjusty time. I'm not sure how far away this triggers. It looks like it triggers pretty close, so I'll just show you what I'm doing here. I can zoom in even more using my my camera. Look how much zoom I can get on this. Have you wanted to see this much zoom? Is this an excessive amount of zoom? You tell me. I think it is. We don't need to zoom in that much. Let's back it off a little bit. Getting a little too close for comfort there. Way back. Come on, way back. There we go. Okay. I mean, if you like being zoomed in that much, just let me know, and we can keep that going. So basically, if you look up here on this little red light. You can see it turn off when a metal object gets near the sensor. Well, hey, actually that zoom was pretty handy. Let's zoom back in. Okay, so when I put a metal object near it, that light turns off. So, yeah, I just need to adjust that so that basically it's triggering at the right time. So I think right now this is set a little bit too high, because if you take a look at it like this, oops, there it goes. So if you take a look at it like this, it's like way above the actual point where the nozzle is going to make contact. So let's take care of that. I'm just going to loosen this up. Let's push it through. And that needs to come down quite a bit, I think. Probably about here would be good. And it needs to come down this far because this Hotend that I'm using is a volcano style Hotend. Let's just see if it triggers. Even that is a little bit too, that's a little bit too high even. So I need to bring it down even more. Thanks for your help in the comments, by the way. This isn't an easy process getting all this working, but it goes by a little bit faster and easier when I have people helping out, so I appreciate that. It needs to come down a little bit more, and we'll call that good. I mean, it's almost touching the surface before it gets triggered, so I think this should be good with how far I've got it down there now. Looks good to me. Now let's home the Z-axis and see if we're able to get that one working. I'm going to click Z-axis home now. Oh, and it shut the printer down. So it says, okay, shut down due to X and Y must be homed before homing Z. So, all right. That's interesting. So let's firmware restart and get this going again. I guess they don't want it like off to the side here, because if it was over here, this wouldn't be able to trigger against anything and you could have some issues. So they want to home X and Y first. All right, fine. I just don't know if X and Y are going to home properly because of that sensorless. So I guess I'm just going to be on standby, ready to unplug this if anything goes wrong. So let's home X. Okay. So stepper Z reports error, drive status, open load, B, exclamation point. Okay. Okay. I'm not sure what that means. Low side short A. It has a short. Open load B. Huh. I don't know if this makes any sense to you, but I guess these wires might be hooked up incorrectly. It's possible. Okay. Loose wire or terminal. Well, it looks like everything's plugged in. This is how I plug in all my printers. So let's take a look. Let me clear out this desk. I'm done with most of these tools now. Alright, so this is what we've got. Okay, so let's see. So this is the Z-axis stepper motor right here. Yeah, we've got our X, Y, Z. So this is the Z, and this runs from here. Runs from here over to this right here. And that's a pretty straightforward cable run. It's right here to over there. That's Z to Z. So I'm wondering if maybe something's switched around. So maybe Creality does another order of plugs. Yeah, so I'll need to switch. Yeah, they're all wired up pretty good. It doesn't look like there's going to be an issue there. So maybe I need to switch the order of cables. This is a pretty common thing to have to deal with, so I'll try switching them around. Let's see what happens. It's always easier to do this with some tweezers, so I'll find my tweezers. In more positive news, I think that means UART is enabled if it's able to send all that detailed troubleshooting information. So how should I fix this? I guess I can look at the wiring diagram and make sure that the wires are set up correctly. So we've got our wiring diagram here. And it looks like it should be just a straight shot with no flipped wires or anything. So yeah, it looks like relative to what we're seeing there, it looks like my middle two wires should be reversed. So see on this end, everything is, let's see that, everything's straight on. When I go up to the other end, you can see those two middle wires they switch places. They're swapped, I think. Yep, they're reversed. So I'll try switching that back around. We'll see if that helps anything. So you just get some tweezers or pliers or some small tool to be able to pop these out. Okay, here goes. So we pop those little arms up, pull these out, and push them back down. Switch their places and push them back in. I wish the 3D printing industry would have made a standard for this by now, but it seems like everybody just does it however they feel like doing it, which is a pretty silly way to do things if you ask me. So we flip that around and I'm ready to retry. So let's see how this goes. And it's a really bad idea to plug and unplug these wires while the printer's turned on. I'm just asking for trouble here because you can easily fry your stepper motor drivers doing this. That's why stepper motor drivers are so easy to plug in and unplug, because just doing stupid stuff like this you can fry them. But anyways, let's try homing one more time. Let's see what we get. So back on our screen, we got a firmware restart. Get this thing running again, and I'm gonna click home, home all, and we'll see what happens. All right, home. Ah, yes. Ah, yeah, that's working. Awesome. Oh, no. Jeez. What the heck is it doing? Why is it going that way? Okay, please stop. This is gonna break something. Okay. So, that didn't work out exactly as planned. Let me go find the part that just got flung across the room. I can't find it. Well, basically this top piece, it's just gone now. Oh my gosh. Okay, well, I think my stepper motor's going the wrong direction. It's like in reverse. So there's probably a way to fix that. But basically this top cover is gone now. It just got thrown out, and the this little linear rail is worryingly far up off the edge there. Like you can see the balls inside of it. Well, I'm not getting the best camera angles on it right now, but I'm just trying to fix this. So, okay, I need to reverse the direction of my my z-axis. That much is known. So we'll go over here. Let's go to our machine. Go to printer.cfg, and then we find our Z. So Z direction pin, add exclamation point in front of pin name to reverse direction. I think that's right. So let's just delete that exclamation point. You can't really see it, but yeah. Basically, it says with the exclamation point, it reverses the direction, so we'll get rid of that. And hopefully that straightens things out, and now things will be going the right direction. So let's, geez, I do not like it when stuff like that happens. I just manually moved the y-axis, the z-axis back down, but basically it kept going until this was off the end, and yeah, not a good thing, and it broke this little part up here. So we'll have to print another one of those out, which is fine. I think the first one didn't look great anyways. But let's save and restart that, and we'll try homing again. Never a dull moment when setting up a new 3D printer, especially a kit build like this where there's tons of problems. and depending on your level of skill and intelligence. You can see I didn't pass that intelligence test, and we had some issues. But let's try homing again. Home all. Okay. It's making me nervous when it moves. Oh, God! Alright, so let's see. Oh no, this is... I gotta move this over to the side so that the probe actually detects something. Okay. It actually triggered there. It would have been off the edge of the bed though, so I had to move the bed over just to make sure that it hits things. Okay. It sounds like running water. Like all these stepper motors have like this strange behavior. It sounds like hissing. Well, anyways, let's try and get that sensorless homing set up. It was clearly doing something weird there. I'm gonna cut the power to the motors and just check what's going on here. So let's turn on the X. Yeah, it's not homing super reliably. I think that's the sensorless homing. It's kind of like not tripping in the right way. So I think the direction is correct. It just needs to be a little bit more sensitive to when it runs into the end stop. It needs to get triggered. So I'm going into my sensorless homing.cfg file. Let's check that out. Warning, do not edit this file. It is a template. To override settings from this file, copy and paste it to the relevant section. Okay, I've done that. Warning, this does not work if you've bent the diag pins on your XY steppers. Okay, I hope I haven't bent those pins. I don't know what that means, but I'm assuming I didn't. I'm just assuming everything's going to work. Okay, so driver strength, stall guard threshold, this is your X sensitivity. Okay, so I want to set this to be more sensitive because it's clearly just ramming into the side there. So I don't know if this should be bigger or smaller. Variable sensorless X current. Not sure what any of this stuff means. Documentation isn't super clear. So sensitivity has to go up and homing speed down. Stepper Bozer is from spread cycle mode. Okay. Too high power probably. Spread cycle has more performance but is louder. Use stealth chop to get rid of the loud noise. Stealth chop threshold 9999 on stepper except extruder because it's not recommended to use. Okay. So unplug the Z motor and then bring the axis down manually. It will go up in the beginning as a safety feature to avoid it hitting something. Okay. Alright, I think the Z's fine. I just need to tweak this X and Y. So you're saying the sensorless sensitivity has to go up. So I'll make it 100. Oh, 100 there. We'll make this 120. Sounds good to me. Save and restart. Let's try this again. But you're saying the speed has to go down. So I will change that as well. So let's go to printer.cfg. Homing speed. We'll turn that down. So homing. There's no more than this. Yeah, I agree with you. I should probably turn the homing speed down so that it's not firing up so fast. Maybe that's in the some other part of this. I'm not sure where I would find that. Maybe in the height map. Okay, well, let's just try homing it again, see what happens. Okay, yeah, that's not great. Okay, so at least the z-axis is working. I'll turn the sensitivity up even more. So Hapsty, I used Polylight PETG for this whole project, and it worked pretty well. So I could recommend it. I haven't really had too much issues with most PETGs, but yeah, if you just get the clear stuff, I find that works better. I've had the least issues printing with clear PETG. Okay, let's go back to sensorless homing. We'll turn that sensitivity up even more. So 150. Get this at 170. Save and restart. Man, this is stressing me out. I thought 3D printing was supposed to be fun. Just kidding. Alright, driver strength, have a maximum of 255. Must have a maximum of 255. Okay. TMC 2209 stepper X. Alright, I must have messed up something in the config. Okay. I did 1500 sensitivity instead of 150, so that's all good. Restart. Okay, let's try that again. Let's home all. Yeah, it's still not working. Why? Why is it so hard to set that up? So maybe I'll just set the sensitivity all the way up, but it could be some other issue entirely. Let's go look at this. Sensorless homing isn't that hard to set up. Okay, Rice Bear, why don't you tell me how many, what my sensitivities should be? And I will do it. Okay, so the other thing is do I have the right stepper motor, like stepper angle? Because it's saying I'm not sure. Try 255? Okay, I'll try 255. I don't mean to sound impatient or whatever, but this is some Baloney. Like, why does it have the default values set so low if it's usually higher than this? I'll try 230 and 240. Save and restart. Alright, then when we home, we'll see what happens. I just read the Minion has to include the end stops. Alright. The thing is I got the mechanical kit only. So I don't have the electrical end stops. Alright, well, let's try homing this again. Okay. Any ideas? That's because the homing speed. You can set it via printer.cfg. Okay, I will update the homing speed. I don't see any. I'll try speed. Okay. I'll try looking for speed in the config file. I'm guessing that information is in another area. So it says include RatOS printers, V-Minion steppers.cfg. So all of this is like tucked away in other areas of the of this stuff. RatOS, homing. All right, so here's all my homing commands. This is like ridiculous. Okay, stepper angle in the config and on the steppers, it should be identical. So I'm using Moon's stepping motor type C17H02024-01N 6128 6367. Yeah, I'm not sure what the deal is with that. It's also labeled as Creality 42-40. So, look that up. So it says 1.8 degree. So 1.8 degree I think is the default. Homing underscore speed 50 for every stepper. Okay. speed. Set speed, travel speed. Z-hop speed, Z-hop. Okay, so I'm guessing this is in a different, maybe it's in the steppers. Man, our set. Okay, includes files of the motor. So, which motor am I using? Let's see. Printer.cfg. Was this supposed to be easy? Okay, so it's saying that I'm using these LDO whatevers for everything, which I'm not. But what I'm going to do is modify that file to be more in line with my what I want. So LDO 42 STH 40. Oh, that's a 4240. That's what my Creality one is. Okay. Okay, 4240. RatOS. Steppers, LDO, 4240. Okay. 2209. Okay. X, Y, and Z. Oh my goodness. I have to go into each one of these? No. I don't want to. Alright. Is it just me or is this kind of ridiculous? Yeah, the Ratrig configs seem kind of messy to me. I'll agree with that. I agree with that assessment, Rice Bear. There's no reason to have all these. I mean, they're trying to automate everything, but it just makes everything hidden behind layers of code. Alright, I'm going to throw some of these stepper motor heat sinks on now because things are getting hot. I'm okay with doing it in a single file. I mean, they're not supporting the type of motors that I'm using apparently. I don't know if that's a correct statement, but it's just the way it seems right now. Oh shoot, I just dropped a heatsink. That could have been bad. Alright. Alright, one more stepper motor heatsink. Yeah, but to make a file for 20 different printers, it would be 2,000 lines and everything would have to be commented out. Yeah. I don't know. It just seems like this half in between state between like something that's fully like automated in the setup and something that you build yourself DIY. Like it might have made more sense to have a configurator generator that's a third piece of software or like a website, possibly. All right, so let's figure this out. Ratrigs are famous for not having clear installation and configuration documents. Nevertheless, they are awesome printers. All right, fair enough. Well, I guess they want me to do like they recommend using sensored homing, but they didn't give me any sensors in the box because I didn't buy the mechanical kit. They sent it over for me to review. So, I mean, it's not the best experience. Like, I don't think there's any way for me to spin this in a positive. Like, I'm not able to get the printer running right now, which is annoying. Check how much power your stepper can cope. The current is quite high for the LDOs. Yeah, these ones can handle 1 amp, according to them. And they're just starting to warm up. They're not really hot at all. And they've been on, just idled here for a minute. So the LDOs say they're good for 0.8 amps. These say they're good for 1 amp. So I think we're fine on that front. I just need to figure out how to set up sensorless homing because right now it's not working. So let's go back to look at some more stuff in the config. I don't think the speed is that big of an issue, the homing speed. I could be wrong. But that, from my experience, if you just have the speed set too high, it'll trigger falsely when it tries to start up. And it won't actually cause an issue like I'm having now where it's not detecting anything. So let's go to sensorless homing config. Variable sensorless current. I'm not sure what this means. Variable sensorless X current. So you know what these numbers mean at the bottom? And then these diag pins. I'm not sure what that means either. So I'll just turn these all the way up to 255, which is their maximum. And if it's not getting triggered then there's no way to get it to trigger. And the issue's probably somewhere else. Like somewhere in this random config file with like 1,000 different include things. Use 75% of the rated current. Okay. So homing speed 50. Well, is 255 mean high sensitivity or low sensitivity? Like maybe I should put the value to 0. Maybe I'll try that next. But I don't know what you guys think about that. Check if you have sensorless homing jumpers set on the board. Okay. Yeah, I'm not sure how to do that because they don't tell you how to do it here. I'd have to watch some other video to figure it out. But maybe I'll get something going on my phone so I can learn a little bit about this.
Today we're going to talk about how.
Okay, I'm going to watch some Ed's 3D Tech channel. In the meantime, I'm going to be looking at my settings here. I just restarted things. So let's try homing. Oh, maybe the sensitivity is set too high. I don't know. Maybe the sensitivity is set too high and it's triggering itself instantly. Hold on. That might be it. Alright, I'm going to try going back here. Sensorless homing. Let's turn these numbers down low. Alright. Save and restart. Let's see. Because what might be happening is it's triggering instantly, and then it's moving. Then it's like, okay, I'm at home. And then it's moving half the distance of the bed to try and do the z-axis homing. So we'll see if that works. And if that's the case, then I think we're onto something. So we'll just try some more stuff out. Let me switch back to boom. And yeah, I do think I need to slow it down. I'm just not sure where to find that information right now. All right. Yeah, I need to slow it down a little bit. You're right, Bula, Balu, YouTube. I just need to figure out where to find that setting. It's in these. It's in here somewhere. Homing.cfg. Z-hop, Z, blah, blah, blah. Set homing, G-code, macro, RatOS, homing.lower. Okay. So it's got to be in the macro folder. I mean, this is like when I've done computer science-y, software engineer type projects. You have to read through all these source code documents and figure out where all the code is, and I just hate it. So this is not the best experience for me, but it is what it is. Okay, so let's go to our macros, maybe. Macros.cfg, and I think we've got our homing things in here. So let's see if we can find our homing speeds. Macro travel speeds, 150. I mean, I could try turning that down. Man. Okay, variable homing end stops. That's not what I want. I want sensorless. Okay, maybe that fixed it. Oh, it's read only. What the hell? Why is that read only? So here it says sensorless or end stops. Possible values, sensorless or end stops. It's set to end stops. And I can set it to sensorless, but this is a read-only file. So, not sure what that's about. Okay. Bah. I mean, this just makes the printer.cfg file useless because there's nothing I can do here. There's like no information in the printer.cfg, and that's normally how you change everything on a Clipper device. But now they've basically just neutered it, so it doesn't really do anything. So I'm going to set this to 50. Right here. Save and restart. Maybe that'll make my my stuff happen slower. Also, this like rushing water noise that this printer makes is like seriously grating to my my mental health. It's like this really high-pitched, broad frequency noise, and it's just bad. So check your pins for pin jumpers for the steppers. Did you include the sensorless homing CFG in printer.cfg? Include? Yeah, I think I did. I'll show you in a minute here, but I'm going to try running this one more time. We'll home all. Home all. Okay. Okay. I'm just turning the sensitivities down to really low numbers. I'm not sure if that's going to help anything. Oh. Yeah, this is terrible. Okay, so, I mean, what's the point of having Clipper if you can't change things in your printer.cfg file? Like, I might as well be running Marlin at this rate. I'm going to see if I can download someone else's Ratrig config, maybe. Or I'll check out Rice Bear. Apparently he sent something to me on Discord. So, uh-oh. We don't want that on screen. That's our NSFW Discord. All right. Okay, so I mean, I would be. This is going to be easier for me to just set up a printer.cfg from scratch, because right now I'm in this terrible in between where it's like I have some changes I want to make, but I can't because we're stuck in Ratrig land where everything's just wacky. So I'm going to just make a printer.cfg file from scratch because this is just not worth it. Check the jumpers on the motherboard, Rice Bear says. I don't know what that means. Oh. I have the jumpers set up according to the Ratrig specifications. So if it's not working now, it's not my fault. I have it set up just like how they're showing here. So if anyone's got a printer.cfg file they can recommend, I will just go with it. Ah. Okay, as shown in the picture, insert the short circuit cap when using the sensorless homing function and do not enter it when not using it. There's no need to cut the driving diag pin. Okay, Rice Bear has sent me some potentially useful information. So I'm going to try that. Let's go back to the board. So apparently the way that this short circuit detection works is there's a capacitor and it fills up that capacitor and triggers some, some stuff when a short circuit is detected. So we've got this turned off. Okay. We got it turned off, and according to Rice Bear, so if this doesn't work, we all know who to attack in the comments section. It says, as shown in the picture, insert the short circuit cap when using the sensorless homing function. What does that mean? I think it's telling me to short these two wires together. It's a thing that's underneath the stepper driver chip, so I gotta pull this out. And then, if I'm understanding this correctly, right here, there's little jumpers there, and I don't have something plugged in there. So I think maybe I need to plug something in there. What do you think? What do you think? So do I need to put a little jumper in right in here. Am I doing it right? Put this little jumper in. My life is suffering. This is the Ratrig 3D printer kit build life. Okay. Alright, is that what I'm supposed to do? Someone let me know. Especially Rice Bear, since you're leading me through this. Let's check the comments. See what y'all have to say. Jumpers always come with a bit board. The short cigarette cap is a jumper. Okay. Yeah, I know what a jumper is. Okay, so that's it? Is that what I'm supposed to do? Okay. Alright, Rice Bear, if this doesn't work, we're gonna have to ban you from the Discord. I'm just kidding. It's worth a try though. Thanks for helping me out with this. Oh man, if this was any other printer, I would have gone through like 10 spools of filament by now and had this thing up and running. But you know, I like my Creality machines because they initially suck and then I have to tune them and get them working just right. So maybe I'll really like this printer by the end of this process. Okay. And I want to turn on Stealth Chop because I don't like stepper motor noise. Like, it makes me want to throw the printer out the window. So I need to figure out how to get rid of that grinding noise that these steppers are making. Some people commented on some of my videos complaining that on Creality machines you can't disable Stealth Chop. And I'm like, why would you want to disable Stealth Chop? That's like one of the best things that's happened to 3D printers in the last 10 years. Like, okay, so I've got those shorting caps. I'm going to put everything back in place. We'll see if sensorless homing is working. All right, So I got my shorting caps installed. Why do they call them caps? I don't know. That's a reserved word in English when it comes to electronics projects like this. So we'll plug this back in. Hopefully those shorting caps don't short too much. Otherwise this will not be a good thing when I plug it in, but let's find out. Okay. No smoke. We're ready to try sensorless homing one more time. So, here goes nothing. I think my stepper motors are driving in the opposite direction that they're supposed to. But we'll get that sorted out after we figure out this whole whatever else. As you can tell, I'm definitely losing my ability to use the right words to describe anything due to the absolute levels of Ratrig fun that I'm having. So, alright, back to mainsail or whatever. I'll talk to the little thing. Alright, welcome to RatOS Local again. Let's see if we can actually home something this time. Alright, so I'll set those those sensorless homing sensitivities to, some generic levels that should be pretty good. I'm going to go to Rice Bear's advice. And see, he says he has his set to 80. Alright, we'll try 80. We'll try 80. I'll try 70 on the X and 90 on the Y, which was the default when I started this whole thing up. Okay. Here goes nothing. We're ready to try sensorless homing again. I need a small victory here to stave off the insanity. We'll see if we can do it. Home. Oh. There we go. Wow. Holy cow, it's working. Ugh. It's a miracle. Okay. I just need to appreciate this for a minute. Alright. And since it kind of did this thing that's a little odd to me, it moved to the far right side and homed off of that, and moved to the front here and homed off of that. So usually it's kind of the opposite. In my experience, it's usually homing in the opposite direction. So I think my X and Y axes might be all messed up. So I'm going to set this X axis to 0 and see where it goes. Yeah, it goes all the way off to this side. So that's telling me that my X and Y axes are reversed in terms of their which direction they should be going. Whew. Alright, so that means we can go to printer.cfg. We'll go down to these. Crap, it's tucked away in some other part of the code. Lovely, lovely, lovely. Okay, so we'll go to RatOS, go to steppers. No, that's not it. Homing. Macros. Is it homing? No, this is read only. Oof. Maybe it was steppers. LDO. 4240. 2209. XYZ. No, that's not it. I was just looking at it earlier. It's probably in printers. V-Minion. I'm not sure how to switch everything around. Okay, here we go. No. Riceberry is being my little guardian angel here, so he's telling me that it should be in printer.cfg. Printer.cfg. Alright. Okay, yeah, so I need to reverse both of these. Get rid of that exclamation point. And we'll add an exclamation point here. I should swap those around and get them going just right. And then the last thing I want to do is activate Stealth Chop so this frickin' loud stepper motor doesn't strip the remainder of my sanity from me. That is a really annoying noise. Okay, so I gotta turn that Stealth Chop on. So RatOS, Stuffers, LDO 4240, 2209. No. Is the Stealth Chop in here somewhere? Is that gonna... I'll see what's going on in Ricebear's config file. Yeah, Stepper X. Okay. So I need to add Stealth Chop threshold 999999. I'll just add it here. Stealth Chop underscore threshold. We'll see if that works. So I'm going to add that to all of my stepper motors. And thank you. I would just like to thank Ratrig for hiding these important settings, tucking them away deep inside of the config file. Because that would be awful if I could just change this stuff easily. Ah, this is read only. Oh my goodness. Oh my. Oh. This is great. Okay. Well, okay, so I'll add the Stealth Chop stuff here. Hopefully this will work. Alright, I'm not interested in the utmost speed because my sanity is more important than the speed that we're attaining. So we'll save and restart. Now we're ready. I think it's going to work. What do you think? We're going to get everything working now? I'm ready. All right. Moment of truth. I'll just make sure that we're seeing. Yep, you can see it. You can see everything. Okay. Firmware restart. Okay. Stealth Chop threshold is not valid in section stepper underscore X. So it doesn't like that I've got the Stealth Chop threshold setting in there. That's great. Okay, so that needs to be in TMC 2209 under space stepper X. Okay. Alright, let's go over to that. My bad. It's not supposed to be there. Alright, so how to enable stealth chop on Ratrig. Maybe Google will have the answers for me. Stealth mode. Okay. Alright. So here we go. They have a stealth mode setting. According to Google. So, alright, that's cool. Let's find it. Okay. Okay, stealth mode. You need to include one of the above stepper motor definitions. This will make your printer quieter but less accurate. It's an inherent side effect of stealth chop. Okay, yes, please. I don't know why stealth mode isn't enabled by default. What kind of absolute mad lads want to be screamed at by their 3D printer all day? Okay, that's good. We just had to uncomment this one line here under stealth mode. And that should do the trick. Save and restart. Okay. Now, let's see if it works. Are you ready? Because I'm ready. Home everything. Okay. The x-axis is still backwards. The y-axis is also seeming kind of backwards. But let's see. What happens when I set y to 0? No, that's not 0. X to 0. Yeah, that's also not the right way to go. It's still going in opposite directions. Maybe it's that printer CFG. Maybe something didn't get saved. Let's go mess with that. I'm guessing that something just didn't get saved there, so I'm going to do the same changes I did before. Basically, just add delete the exclamation point between YDAR pin and add an exclamation point before YDAR pin. Save and restart. And with any luck, we should have a good printer. Home all. Yeah, there we go. Homing on the left side. Great. Now homing towards the back. Very good. On the Z, there you go. Ooh, that's great. Okay, now let's turn these motors off and I want to check something. Because it looks like if I had a spool that was up like this, the fan would almost run into it there. It could potentially run into that. I don't think it's going to be a problem. It's not an issue. Okay, well, I don't want to disappoint you all, so let's get something printing. Let's see if this thing actually works. I would be remiss in my duties as a 3D printing whatever if I didn't actually print something right now. So let's do it. We got our filament loaded up. I've got a little bit of Bowden tube. Whew! Yay! All right. We got that. We'll plug in this reverse Bowden tube, as people like to call it. Cut this a little bit shorter. Doesn't need to be quite this long. Maybe about that long. That'll be it. That'll be good enough. Alright, hopefully this works. I actually haven't tested this extruder yet. So I think what we do is... There we go. Just loading that filament in. Ah, nice. Okay. And I think I should be ready to print here. I have to tune my Z offset, but we're doing it live. Alright, let me check in on the chat. Thanks for the help, Rice Bear. That really helped out. If you can't tell, I'm no longer having fun and I'm just trying to get this done. Okay, it's in printer direction. Hold your printer upside down to invert. That'll work. That'll do. Yeah, X stepper and Y stepper were inverted. We finally got it sorted out. Alright, now Rice Bear is asking for free stuff. He wants a free channel subscription, which I guess I can subscribe to your channel, Rice Bear. I'll give you a sub. So after this, we'll do it. Next installing, okay. On every stepper except Z, you don't want that. Oh yeah, I have it on the Z axis. I should probably get rid of it, but you know what? It's too late now. I didn't need to add that capacitor. No, it's not a capacitor. I don't know why they called it a cap. But I probably didn't need to add that short pin on the extruder or the Z axis. So if I take that out later, don't be surprised. I'll probably do that off camera. Because I've had just about enough of playing around with the electronics on this thing. I'm ready to print. So, let's see if it can actually print. I wouldn't be surprised if it doesn't work. So, I'm going to turn on the extruder and tool head. So right over here, let's just set these to PLA temperatures. Let's say 210. Set this one to 60C. And just like that, these things have fired up. We've got our fan spinning. Our little Noctua fan, super quiet. Very quiet little device. I always love these little Noctua fans. Okay, so that's all good. This bed is heating up, and the hot end is heating up. So, this is a good start. I'm going to find some Benchy G-code I can drag and drop onto here. I'll put a relatively fast Benchy on here because we don't need to hold this thing's hand. It can go fast. It should go fast. It's got to go fast. I'm going to put this cooling duct on as well, so that just goes back here. And I need to put a couple fasteners in there. So everybody, raise your hand if you have lost a little bit of your sanity watching this live stream. Just even a little bit. You know? Don't worry, this won't be used in court. I just want to know for internal purposes. So as you can see, this printer is nice and quiet already, thanks to this fanless power supply and my Noctua fan. Fanless power supply is the way to go. These things aren't cheap, but if you can find one secondhand, you could probably find some in like a surplus store. These Dell power supplies, they're also used on Alienware laptops. So any type of laptop that consumes a lot of power, that might be a good use for you. Okay, I just gotta find my little bolt box. Gotta, whew. Alright, and the filament smells hot. And it can extrude. We gotta, yeah, I can just squish that filament right out there. Okay, so anyways, gotta find that box of screws, because that will be important for finishing this up. I wonder if I took it somewhere else. I'm not sure anymore. Oh, there it is. Okay. So, just need 2 nuts. I'll load them into this little part. I printed out really nicely on my P1P. And put them there. And I just need to use one of these screws. Alright, that was the right length screw, but I don't know what type of screw it was. It's probably one of these guys right here. This is a 16 millimeter, so it's either 16 or 14. That's the right length for that. I'm guessing it was actually a 14. That's the yeah, it's definitely a 14, so let me switch that out. Let's get 2 14s out. All right, let's see what the what's going on in the comments section. All right, we got at least 3 hands raised for loss of sanity. I will not be held responsible for your actions after you've lost your sanity. That is not my fault. It was your choice to stay here and watch me suffer through this whole installation. So I will not be held responsible for that, but it's good to know that I'm not the only one that's going through some mental changes right now. Gosh, this is ridiculous. Kit printers aren't for everybody, but, you know, if you enjoy this kind of thing, then there's nothing else quite like it. Yeah, I think actually I need 12 millimeter screws, so we're doing 12s. You could have prevented this. You made us suffer too by not setting the jumpers. All right. Fair enough. I still don't have the jumpers set correctly. I have them set on the extruder and the Z-axis, which is probably going to cause all sorts of problems. I'll actually fix that real quick before I start this this first print job. But yeah, this thing's nice and quiet, at least. Oh no. Okay, 12s are too short. It was 14s that I needed. Alright, we're finally ready. Ha ha ha, alright. So let me unplug this and just get those, pull off the caps on the ones that I don't need, whatever on there. I don't even want to think about what the right words are. So let's take those jumpers off on the Z-axis. Alright, and we'll take the jumper off on the extruder. And we're ready. So I'm just going to go for speed straight away. The rational thing to do would be to just load up a simple print job on here. But given how much this printer has made me suffer, I'm gonna make it suffer, and I'm gonna throw a challenging print at it right away. So I sliced a 40-minute benchy. Oops. I sliced a 40-minute benchy already that I used in my P1P and my Ender 5S1 tests. So I'm just gonna drop that on here and see what kind of speeds we can achieve just with this printer right out of the box. So I gotta refresh. Ah, Joey showed up. Thank you, Joey. I'm glad he didn't show up until now because he's already crazy enough as is, and if he had to sit through this 4 hours of pain and suffering, 5 hours, I don't think it would be good for anyone. Okay. So now all I'm going to do is just drag and drop that G-code on, and we'll see what we can print. And the G-code, where is it called? Oh, Joey, thank you. Thank you, sir. Very kind. Well, Joey, I'll tell you what you missed. Basically, it took me about 2 hours just to get this thing working once I had everything assembled, because I was really fumbling through basically the configuration on this machine. It's got a special RatOS thing on here, and it's like Clipper, but they've kind of split it up into a bunch of different files and folders, which just makes things more difficult than it needs to be. But we're ready to just throw some stuff on here and see how fast it prints. I'm just trying to find my G-code for it. So, G-code. All right. Okay, I'll find the G-code I sliced already. That way I won't have to slice it again. Well, shoot, I might just want to slice it again. Nice. Don't worry, Joe, you have the right to annoy me anytime. Okay.
I'm realizing I must have sliced that further ago than I thought I did. Okay, well anyways, I'll just slice it again. It's not a big deal. Ooh-wee. So, slicer time. Benchy, a 30 benchy. Let me just get you the full screen experience. Here we go. Whew. Okay, I've got it now. 3D benchy. Okay, there's our benchy. There's some, oh man, that's not right. That's the multi-material benchy. We don't need that. I just need the regular benchy. Okay, so we got this loaded up. I'm just going to move it to right about here because that should be about centered on the smaller print area. This is all my slicer settings for the Ender 5S1. I'm just going to be printing it using those old slicer settings that I came up with. So we're going to discard all the changes and we're just going for NBR fast. Alright, we'll give it a slice and see how long that takes. Okay, it's saying 40 minutes. Oh yeah, that's because I got support on. Let's turn that off. And here we are, 35-minute benchy. This will be a good first print, wouldn't you say? So I'll get this exported. Rat test. Alright, time to load up the rat test and see what we can do. Alright. I don't know where I saved it to. Okay. It's in downloads, rat test. Here goes nothing. Sorry if I'm a little slow now. It's just a little mentally fatigued after all of that. Okay, rat test. Here we go. We're ready to do a test print. After all this time, it's time for this little Ratrig to prove itself. So here goes. Start the print job. Okay. Alright, I'll switch this over so you can actually see what's going on, because you probably want to see the printer do its printy thing after we've waited so long for it to do anything. And I'm going to have to adjust the Z offset while this is going just to make sure it gets started correctly. But after that, we are all good. We're getting up to temperature. It looks like the extruder's up to temperature already. That thing heats up really fast, despite being at the lower voltage. And our heated bed is just about up to temperature, so that's all good.
Yeah. Well, thanks, Joey. I'll be able to get a couple more pairs of pliers with that donation. I'm only slightly kidding. Everybody knows that you can only afford about 1/10 of a pair of Nipex pliers if you're, wow, with a donation of that size. But I think I've got all the pliers I need for now. And it looks like my Z offset is almost spot on. It needs to be reduced a little bit. 0.1, maybe. I really do need to change the Z offset. I don't know if there's a way to do it here. But this is all... none of this is going to work. This is looking really bad. So we're going to need to restart. But how do I change my Z offset? Is there any way to do that? No? Okay, we're canceling that. I mean, this is looking really good, but I just need to move the Z offset down just a little bit. So I think I need to go down maybe down 2 of these and save. We'll see if that works. Because that's just not going to work without that adjustment. So G-code, let's run this test again. I haven't done the leveling of the, like doing mesh bed leveling or anything, or any type of tuning. I'm just getting this thing running and just seeing what it can do. Now let me turn on my little screen here. I'll be doing a little bit of calibration while we get this started. We got a little picture-in-picture action going. So I'm going to do my Z offset. I found the buttons for it. It's right here. So I just need to tune in those Z offsets as that first layer is going down. I'll turn the speed factor down to like 20%, maybe 10%. That way I can actually get the Z offset tuned in while it's printing the first layer. But yeah, after that, we'll be all good. Do a mesh look at the purge line. Yeah, I don't... yeah, I think this bed isn't perfectly flat for some reason. I'll have to look into that a little bit later. Might have to add some little shims underneath this this bed just to get everything tuned in just right. But I'm excited to just see what this printer can do. I mean, I've spent, holy cow, like 15 to 20 hours on this thing. If you include the time spent printing out these PETG parts. I mean, that didn't happen instantly, and I had to print them out several times to get it just right. But I think we're finally ready to taste the fruits of our labors and see what we can do. All right, we're up to temperature, and I think we're ready to start printing. Oh, right, but I turned the speed factor down, so it's moving down really slow now. Maybe turning the speed factor down to 10% wasn't the best idea. Let's speed it back up. We're stuck in slow motion right now. I think it's traveling like 5 millimeters per second at this point. Why did I do this to myself?
Yeah, let's see the spurge line. Yeah, it looks really nice. Spurge line looks really nice towards the back, and then towards the front it's a little wimpy. So the bed is probably tilted a little bit. And this print surface could probably stand to be used to be could stand to be cleaned up a little bit. I'm gonna get a little wipe to clean it up. All right, I'll get one of these alcohol wipes. I like these. These are for cleaning like lenses and screens, but they're nice little clean wipes that I can use to improve my bed adhesion. I've had really good luck with them. Okay. It's going real slow. Alright, so I'm going to have to do this Z offset live in 4K. And we'll zoom things in a little bit more just to see what's going on. Oh man. Okay, I'm going to move down a little bit more. Am I doing the wrong Z offset? Okay, that's looking a little better now. I'll have to save that at the end. For some reason it's... Oh yeah, this is a bridging operation. Technically it's bridging because at the bottom of the benchy you've got that text, and then it's writing over the top of the text, and I have the bridging settings set to slow down because I always want bridging to look good, but you know, I guess that's a good thing. It'll improve my quality there. Alright, great. I'm gonna have to restart. I'm not getting good bed adhesion. So I'm gonna save this Z offset and then restart that print job before it cools off too much. Alright, G-code, we'll run this.
Alright, everything's up to temperature again, and we should be getting started shortly. Okay. That speed is way too slow. Okay, I can turn it up. Get a proper build surface. You can't even do a mesh with that small PEI sheet. Yeah, that's true. I need to get one that's a little bit bigger. But I'm just, making do with what Ratrig sent me. They didn't want to send me the full kit, so they just sent me like little bits and pieces, and I'm making do with the rest. Next time I'd ask for a full kit because I spent a lot of time just trying to source components and making it work with other components. But yeah. Okay, now you can see this is, we're getting some skipping because the nozzle is like pressed way against the bed. Oof. Okay, but yeah, it's looking better over here. So I think the bed is kind of slanted this direction. So like this. Like it's high on the left side and lower on the right side, because as I move to the middle here, we've got excellent first layer distance. But on the left here, it's too close to the print surface. So that would all be corrected by using the mesh bed leveling, but I didn't have that set up for this particular print. And if anything here, it's a little bit too close to the print bed. But yeah, everything's looking good now. We're doing some bridging, so slow bridges, sorry about that. We can definitely do better in terms of print profile tuning. But one of the things I really like about this printer right off the bat is how much visibility you have. It's really easy to see what your print is doing. It's looking pretty good. This is looking pretty good. I'll pull up the speeds on this little screen here. We'll zoom in on it. So, I mean, our flow rate is kind of varying, so is our speed. So I'm requesting 200 millimeters per second, I guess, for all of these print moves, and it's limited by acceleration, but I mean, this is looking pretty good. I'm going to zoom in a little bit more here, just so you can see what's going on a little better. But the print quality is looking nice. And it's nice and quiet too. I mean, can you really hear it? It's making some cool little stepper motor noises, but for the most part, it's not really making any noise at all. Doing some bridging, so of course it's going slow, just because of my slicer settings, but overall not bad. I don't know, what do you guys think? Is this a pretty cool printer? How did you cut the sheet? I was using, I think, a Dremel and like tin snips, those really heavy duty printers, snippers, scissors, words. So probe_calibration should work and be much easier, yeah. Oh dang, sorry Namion, yeah, I should have posted something in the Discord. What kind of step sticks is it rocking? Step sticks. Yep. Memory 3D printing in the other room, way more with a headset on than this thing. Yeah. It's nice and quiet, especially with stealth mode turned on. It's doing stealth chop. Pretty handy little efficient printer. Well, I don't know why everybody loves their Ratrigs so much, but I think part of it is just the amount of time you invest into building it. Like, you might spend $1,000 for a 3D printer if you get like some crazy upgraded Bamboo Lab machine. But this, you pay like anywhere between anywhere between like $400 and $600 for it. But then you invest 20 hours in it, and what is your time worth? I mean, even if your time's just worth, $10 an hour, you're investing $200 of your time into it, and then it's all of a sudden it's one of your most expensive printers. So, yeah. Well, I'm glad to see it's working after all this time I spent on it. Putting some nice layers down. I'll get you right up close. I'm gonna make sure my okay. Yeah, I was just making sure the sound is coming from the camera, but we'll get you up close and personal here. And you can see when it's doing these slow moves, it's extremely quiet. Aside from the part cooling fan, but you can turn that down a little bit if you want to. So, nice little printer. Is this too much zoom? What do you think? But yeah, visibility is pretty great on here. I'm going to do a decibel test just to see how loud it is. So I'm going to be at arm's length. Here's my arm right there. 1 arm's length away. Let's see our decibel readings. So it's looking like it's about 45 to 48 decibels. When it's making the most stepper motor noise, it's about 48 to 50 decibels, but it's always under 50 for the most part, and most often it's around 45 decibels, so pretty quiet. I know this Spadis Hotend that I put on here can handle some extremely high flow rates. So what do you say I just crank this up and see what happens? Are you ready for some speed? I don't think it matters if you're ready for some speed. We're gonna push this way faster than I should push it on a first sprint and just see what happens. I think we're ready for the challenge. Okay. Send it. Alright, that's all the confirmation I needed. So we're gonna go over here and let's just go ahead and go to the speed factor and we'll just go whoop. There we go. 200%. Let's go. Oh, 300%. Let's see what 300% does. It's probably acceleration limited at this point. So we're gonna need to go and find that acceleration setting and crank that up too. Alright, 5,000. Oof. Let's turn the velocity settings up. So I don't know if it can handle 300 millimeters a second, but we're going to find out. Print quality is still looking pretty good, and keep in mind this is without any input shaping yet. So this is probably a dumb idea, but I'm going to go ahead and turn this up to 8,000 millimeters per second squared accelerations. So you can see there's our accelerations. We'll turn our accel to decels up to 3,000. It's making like a kind of a honking noise. That might be coming from the spool though. So I'm gonna spool out some extra filament so it doesn't rotate. Yeah, there's definitely like a honking noise that it's making. Not sure where that's coming from. It's going. But overall, it's nice and quiet. So I'll give this pretty high marks on printer noise. It's kind of a funny noise. I think maybe I need to tighten up these belts a little bit. But, you know, this is pretty impressive. 8,000 millimeters per second squared acceleration, pretty high speeds. I'll bump it up to 10K. But you can see we're requesting some pretty high flow rates here. Speeds are getting up there pretty high as well. And so far no major issues with the print. I can see some ringing, but what do you expect on a print going this fast without input shaping?
Ah, oh, jeez.
This is pretty crazy. Alright, I'm going to turn up the speed a little bit more too. So, we'll try... Wait, the acceleration's turned back down. Sometimes it does that when it switches from doing a bridging feature to some other stuff. The firmware, the slicer will be assigning some accelerations that are different, which is not a huge deal. We can just turn that back up to 10,000, see what happens. And we'll turn our max speed up to 400, which is a really bad idea. Well, I'm curious to see if it can handle it. This is like a Bamboo Lab print speed. Like my P1P will go this fast, but this is significantly quieter. Okay, now you can see it transitioned to doing some bridging and it slowed itself way down. But I don't see any major print quality difference when I'm changing the acceleration like that. Like overall, this seems to be a very well-designed machine. So I'm just going to let it finish up, going at whatever speed it's going at right now. Maybe I'll just... Everything's going to be acceleration limited, but I'll just turn the speed factor way up and set my maximum velocities very high and just let it go. It's just going to be kind of locked in at this 5,000 millimeters per second squared acceleration, which is relatively fast. I was having more print quality issues on my Ender 5S1 at these speeds. So, if a cantilever printer like this can go faster than a cube style printer like the Ender 5S1, then it's obviously doing something right. Like this is better than pretty much any Ender machine that I've used. Except for my highly modified Ender 5S1 that I put the sonic pad on and did input shaping and all that stuff. That has a little bit better print quality than this, but the difference isn't huge. Like this is remarkably good print quality. I'll zoom in a bit more. Hopefully you don't get motion sickness because this boat is rocking. But yeah, there you go. I'll get a different perspective. Maybe it'll be a little less shaky this way. Alright, we'll just let this thing chill and print, and I'll answer some questions in the chat. Yeah, alright. I'll do a bump. Get her done. Gotta go fast. You can adjust the mic input volume in OBS as well. Yeah. Stepper board. Does it look like TMC XXXX? Yeah, step sticks. Okay, that's what you were going for. I just noticed that your mic volume is fairly low. I can turn it up and still hear you, but I need to remember before I jump scare myself before I watch anything else. Okay, yeah, I can turn up my volume a little bit. I would need to do that through my camera. I think I just forgot to put my normal normal microphone on here, so it might be a little different audio than what I'm usually doing. Stepper boards, yeah. Does that have screws to level? No, it does not. But if you look under there, you might be able to just barely see what's going on. In this stack up, we have the bed, then a nylon washer, then the stainless steel spacer, then the aluminum plate, then another nylon washer, and then a nylon lock nut. So if you tighten it down enough, you might be able to get the nylon washer up top to squish a little bit, but you're really not going to be able to get much adjustment out of it. Does that have bed level screws? Yeah, so no. I like little printers. Yep, this is one of the best little printers on the market. It's just requires a heck of a lot of time investment to get it running. That said, I mean, if you're looking for the best small printer that you can put together and you don't mind spending the time assembling it yourself, then this is, for sure one of the best options out there. And with this Bondtech LGX Lite and the Rapido Hotend, I mean, both of those together are producing some fantastic print quality. Once I get the ringing dialed in by doing some input shaping, getting that, canceling out some of those resonant frequencies, I think I'd be able to get some pretty dang good print quality out of this machine. Not much in terms of ringing either. I mean stringing. Not much stringing going on. This is also using Fadis's tungsten carbide. I don't know if it's tungsten carbide or if it's pure tungsten for the nozzle. It's a very hard nozzle with relatively good heat transfer properties. Gotta go fast! Limits are in the printer.config, and Clipper will need to restart for them to take effect, so don't do it mid-print. Well, the ones that I can change on the slider here, those are pretty easy to change. These ones. That's one of the big things with Clipper, is that you're able to adjust stuff like this on the fly. It really helps for when you're trying to tune things. And then you can save these settings to the printer.cfg in some weird way, but I find the best way to do it is through your slicer settings. The new Kingroon KP3S that comes with Clipper looks nice, but I couldn't get a Sovol. Oh! But I could get a Sovol SV06 for about the same price. I did not know Kingroon was coming with a Clipper machine. I'll have to check that out. I didn't really like their last machine, so they probably aren't going to be eager to send me another one. Basically, I was just getting garbage print quality out of it the whole time. But yeah, that's fine. Also, for the SV06, I've got a review coming out for that too. Just a really basic print experience review that I put together. The title of it is going to be half the print quality for half the price. So, it costs less than half as much as a Prusa i3 MK3S, but it's pretty low quality. I didn't find that it printed well right out of the box, and there was a couple issues I needed to fix. But once I fixed those, it produced some excellent looking prints. And the only thing that could really use work on it is the part cooling fan. And there's some specific issues to that machine that I definitely had to fix. It was skipping some steps just as the stock machine. Yeah, so impressive for a small unit, but impressive for a small unit, but it goes to show what can be accomplished when it's hand built and made sure it's done right. Yeah, that's the other nice thing about assembling a kit printer, is I took a lot of extra time making sure things were aligned properly, and they're using high quality linear rails, so it just gives you a really good idea of what kind of print quality you can get when something's built right. When you look at all these cheap budget machines like Ender 3s and the Sovol SV06, they're okay, but they're not going to get you as good a print quality as something where someone meticulously assembles it and pays attention to all the little details. Bro, I felt a strong sense of accomplishment when I finished building the V-Core 3.1. I just stood there and stared at the printer for 5 minutes. Then I realized I had to move the 400 millimeter printer. Ah, geez. It's 400 millimeters. That's pretty big. V-Core 3.1. Is that a Ratrig? Ratrig V-Core 3.1? I'm going to look it up. Yeah, so it looks like you're talking about a Ratrig V-Core 3.1. I'll pull it up on the mini screen so you can see what's going on here. V-Core 3.1, customize and add to cart. So it looks like there's some options you got here. So build volume. Okay, so you got the big boy, but not the biggest boy. The biggest boy is the 500 millimeter. Man, I would like to build one of those. This one's a Core Kit V1.3. Yeah, if Ratrig wants to send me one of these, I will gladly spend the 20 to 30 to 50 hours putting it together. I mean, this whole process wasn't super fun for me, I'll be honest. It was painful at times. I felt lost for about half of it. But now that everything's done, I'm just going to have this be one of my favorite printers, just kind of sitting in the corner. When I need to print and just have something that comes out nice, I'll use it. And I don't foresee it requiring a lot of maintenance. So, it's a solid build. Prints are looking really good coming off of it. So, yeah. As soon as this print finishes, we'll pop it off the build surface and take a close look at it. But yeah, that V-Core looks awesome. I mean, I'm a bit of a Ratrig fanboy now after putting this together. Cool. Alright, well, I hope you have fun with your V-Core 3.1. How long have you had it put together? Savage Soldier. So if that has bed screws, I would highly recommend adding the screws tilt macro, making it leveling a ton faster. Yeah, there might be a way to add shims under it to like get it to be perfectly level. Also, I could loosen up the whole structure a little bit and like kind of tilt it to get it just right, because it's possible that those corners, those angles aren't perfectly square. So that's something I can look into in terms of additional calibrations. Or you can just let the printer take care of the calibrations on its own by just turning on automatic bed leveling. The King Rune machine was out for a long time. Yeah, but apparently there's one that comes with clippers, what he was saying earlier. So, that's nice. The screen is showing the adjustments for things. In the printer config, you can adjust all the actual limits and allow you to adjust to higher speeds. Yeah. I think, well, I don't really want to mess with it, but it seemed like it sped up when I was playing with the speeds. But I could be wrong there. I just want one where I can turn it on and not have to fix it all the time, like my oscilloscope or drill. Yeah, 400 millimeters cubed is massive. I would really like to see that 500 millimeters cubed. That would be quite a blast. Have I tried the Triangle Lab CHC? Yeah, I have it on a lot of printers. Probably, like most of the printers that I modify, I just throw a CHC on there because it's just so convenient. I like how it takes what is usually 5 different components and just condenses it down into one little block that you install. I say 5 because you've got the heater block, the heater cartridge, the thermistor and then the screws to hold everything together. With the CHC, you just get it as one solid little piece and you install it, and there's a lot less fussing around, and it's a lot safer because it's a PTC ceramic heating element instead of the metallic one that can do thermal runaway and melt aluminum and cause things to burst into flames. So I don't know if I've done a video specifically on the CHC, but I've just done a lot of, like most of my mods, I throw a CHC on there. Probably about half of them. 50 print hours, you gotta put that thing to work. Yeah. Is the VO2 the really small one? It's like the Voron 0.2. But yeah, look at this thing. It's looking great. I would really like to throw a battery pack on this thing and just have it be like something I can just throw in my car and bring to a work site or something and just show off some, throw out some 3D prints on the spot, you know? And like with how easy it is to see everything on here, it just makes it all the more enjoyable to print with. Because you can just, you just look at it and there's no huge hot end blocking everything. Like when you, the perfect example of that is on the Ender 3S1, your whole view of the print head is blocked, so you can't really see what you're printing. With this, you get to see everything, so it's nice. I think there might be something going on with my x-axis. It's making a little bit of a honking noise. It's really not that loud. But it could be a bearing in the x-axis stepper motor, or maybe the belts aren't tight enough, or maybe, the x-axis rail or the idler on the other side. So I don't really know what's going on, but it's making a bit of noise. I don't think it's actually going to cause any issues, but it's something that if I really wanted to dive in and get this thing working as perfectly as possible, I might investigate it a little bit more. But as is, it's working great, and this is better print quality than I get on my Ender 5S1. So pretty shocking how good it is, really. I'm going to go grab my other benchies that I used for my latest print tests. I'll bring those up here so I can just compare those side by side with this one. It'll be a good little test. All right, Benchy's finishing up. Ah. All right, so let's see what we got. So here's our print. Looks pretty good. There's a little bit of waviness on this front edge. And I guess like there's a little bit of coarseness there too. So it's not perfect print quality. But that said, I did just throw this together and this is the first print. So it's only going to get better from here. Here's my P1P Benchy that printed at similar settings. And then here's the Ender 3S1. So, you know, I'm not a big fan of just like over-analyzing print quality and making a big deal about it. But I will say that basically all the printers that we have access to nowadays are fantastic when it comes to print quality. These are all great. So this is the Ender 5S1, my modified Ender 5S1 with some suboptimal filament. Here's the Bamboo Lab P1P. And now here's the latest edition, the Ratrig V-Minion. There are some weird artifacts, but I mean, this is a kit printer that I just finished putting together, and there's a couple things that I need to check and tune and maybe grease. So, I mean, I don't know what you think about that, but I think it looks pretty good. All right, so this was sliced using Prusa Slicer. So, yeah, I kind of want to try out some of the Vorons. I haven't tried any of them at this point, but I'd really like to get started with trying out maybe the V0, or just go for the biggest one they have, because I like big printers too. I like being able to print out large items. You have a lot more freedom with what you're producing that way. But what do you think about the noise profile of this printer? Is it too loud? I don't think so. I think it's pretty nice. Very quiet. Fast, efficient. Just the only thing is it takes forever to put together, and if you get stuck in the documentation sometimes, like if it's not covering exactly what you're doing, then it can be kind of challenging. That could be mitigated by purchasing the full kit where you've got all the parts that they recommend, which should make it a little bit easier for you. But I like this build. We got the good old Ontech LGX Mini and the Rapido. I think overall those two pair together very well to make a pretty high performance machine. Yeah. All right. Well, any final questions, anyone? I think we've kind of fulfilled the destiny of this stream. We finished the whole thing. It's done. Now it's just time to do a little bit more tuning and testing, and I'll be able to make a full review video about it. Get a 0.2 or Trident. I've heard there's also something called the Salad Fork, which is like a mini version of the Trident. I saw a couple of those at East Coast Rap Festival last year, and they looked pretty cute. But I don't know if there's that much documentation for that one. I know that the V02 has a lot more documentation from what I've seen, as well as the full-size Voron. All right, well, thanks everyone for joining. It's always a pleasure to do these streams, and especially I want to say thanks to everyone who donated and who helped me out with the assembly process, like when I was getting stuck. Because this would have taken even longer without you guys, so I really appreciate the contributions and whatnot. So make sure to check out the full version of this video. I'll probably do a full review on it, just kind of summarizing my experience with it. It'll take a little bit more time to tidy up those wires in the back and maybe do a little bit more tuning and perfect the print quality. But overall, you saw the whole experience. If it's something that you think you'd like, then check it out. Go to ratrig.com and check out the kits they have for this V-Minion. If not, then just stick to having a normal printer that you don't have to spend 10 to 20 hours putting together. Yep, top notch. Thank you. Good stream. Looking forward to the SV06 video. Yep, should have it out at the latest next weekend. But hopefully I'll have it out in the next few days. Have a nice weekend. Have a nice weekend. Have a nice week, everyone, according to Jay Cannon. Yeah, we'll have a good one. All right, to answer Namion's question, the Trident is, it's like a different printer altogether, but it's very similar to the Voron 2.4. Glad to see it's finally done and you can print really well with it. Always a good feeling. Can't wait to see your K1 review. Oh yeah, dang, when that gets in, yeah, I'll probably do a comparison and benchmarking video. Just make sure that it doesn't have any blatant quality or engineering defects. But if it's as good as they are claiming it is, and it lives up to expectations, then I can't see why it wouldn't be a top recommendation, because it's undercutting Bamboo on cost, and if it's more maintainable and easier to get off the cloud, then I think that would be a huge improvement over what Bamboo Lab is offering. All right, well, again, thanks guys. I'll see you in the next video, and let me know if you want to do any more streams like this in the future, or if you have any recommendations, just leave them in the comments on this video. Okay, thanks, and bye.